Hello again, everyone. That was great watching Simon solve that. I'm very happy that we did that. It was well timed so that we all sort of hop over there together and then hop back and finish up this puzzle by Mormagli that we were watching. So if you're new to my channel and you haven't ever come here before, welcome. I hope you enjoyed Simon's solve of MIA, and I hope you will enjoy the various puzzles we're doing today. So we're going to finish up this puzzle, and then next up, if you want to see very difficult puzzles, next up we're doing a Jesper's yin-yang puzzle, which I have heard is quite challenging, so we'll see if we can solve it. But for now, let's get back into this puzzle. So this is a German Whispers V puzzle. So along green lines, digits that are adjacent have to be at least 5 apart, and on all the V's, the digits have to sum to 5. Let's see, and Sayori says 6 in row 8. 6 in row 8. 6 in row 8, right. 6 in row 8 can't be over here, because it can't be there. I can't put a 6 here, because I'd need to double 1 it. So the 6, therefore, needs to be here exactly. Very good spot, Sayori. How long is left on the Setter's Challenge, Tristan? Tristan is keeping track of all the submissions and whatnot. There is an ongoing Setter's Challenge if you are interested in setting. You have 1 week. The details are all in the Discord channel. So if you want to set me a puzzle to have me do, that is available to you. So this is 2, 3, 4. Oops. All right. Great spot. Colored Whisper Dance. Hooray. Is that our first? That's actually our first Colored Whisper. Wow. I am impressed with that. Okay. Somehow we've made it this far without them. So there's a 6 up there somewhere. So now we're supposed to ask about 6 in box 2. 6 in box 2 can't be on this whisper, can't be in this column, isn't 2, isn't in a row with a 6, isn't 5, so 6 in box 2 is here. Thank you, chat. So that's going to sort out this. So this is going to go blue, blue, orania, orania. So this is 2, 7, 1, 6, like that. Oh, the rainbow penguin. Oh, yes, Tristan, can you repin the link? This is a first for pausing the stream to go watch Simon do a solve. This 1 sorts out this 4 and this 1. This 2 isn't up here anymore, so therefore the 3 isn't down here anymore. 3 goes with an 8 or a 9. 1 in row 2 looks right. Yep, just got that. One of these is a 4, and the other is a 7 or an 8. Let's see, 7 in box 3. 7 could go with 2, right? 7 can't go here, but 7 could go here, going 7, 2, 8, 9, 3, I think. 3 in box 2. Let's see, 3 in box 2. Okay, 3 in box 2 is definitely on the whisper. Do I know more about 3 in box 2? I must know more. 3 is only next to 7 and 9. Sorry, 3 is only next to 8 and 9. Boy, is my whisper logic not good today. Oh, sorry. I know the 3 is here, because there's pencil marked 3s over here. So there's a 3 down there. 3 only goes next to 8 and 9. So this is actually a 3-9 pair. That's the point. So therefore I know what this is. This is a 2-7 pair. And now that tells me the order. Because 7 can't go here because 7 isn't next to 3. So it actually goes 7, 2, something, something. And so those are the highs. These are the lows. And so we go 7, 2, 3. And then this is an 8 or a 9. I don't know which yet. Ooh, sweet. 1,300 clicks on the MIA link. That's awesome. Let's see. That 7 gives me an 8 here if I pay super close attention, which is not one of my strengths in Sudoku puzzles, but we'll do our best. Okay, so that gives me a 1 and a 8. 1 and an 8. This is a 1, 8. Yep. So then these digits are a 2, 3, 4, 5, 6, 7. These are a 4 and a 7. Okay. 1 in row 7, asks Sayori. So 1 in row 7, I think it could be here. It can't be any of those places. Oh, yep. Very nice. Okay, yeah, 1 in row 7 is actually fixed miraculously because it's not high and it's not in the box that already has a 1. So it's a 1 and a 4. That's a 2. This is not a 1, 2, or 4, so it's a 3. So that fixes this. These two are the highs. These two are the lows. And so that goes 9, 3, 8, 1 up there like that. Yes, if you have not yet liked the stream, I would greatly appreciate if you all liked the stream at exactly the same time. YouTube really likes it when people do that. Let's see. Box 7 can be solved now, I am told. Yes. Box 7 can be, because this is now high, so that's high. These two are low. And so this 4 is what did that. So that's an 8, that's a 3, that's a 9, and that's a 4. So this is not 1, 2, or 4, so it's a 3. Beautiful naked single. This is not 2 or 3, so this is only 1 or 4 is the answer. Let's see. These two digits. What are these two digits? I should probably ask that. 2 and 3, 4, 5, 6, 7, 8. 2 and 8 is the answer. I'm going to go with no, Tom, although I think actually there is something to like liking and unliking it, but that's deeper than I'm willing to go down the rabbit hole of trying to be a YouTube celebrity. Sixes in box 5. We had 6 pencil marked into this column, but now there's a 1 in this column, so 6 can't be in either of these cells, so therefore this is the 6. So that's the 9. So these are not 9. Can go ahead and demote those. Let's see. We can learn some stuff about the bet cell. So we've got 2, 3, 4, 5, 6, 7, 8 going across here. This one's not a 2 or a 3, so it's orange. This one's not a 3 or a 7. This one looks like it could be anything. This one also looks like it could be anything. Most cumbersome. I am definitely faster solving with chat's help. I think there are probably some puzzles, like if they're on the easier side, I might be able to do them faster just by doing them with myself and not talking. But usually the puzzles I tend to do on stream, I am not confident I could solve most of the puzzles that I solve on stream without chat's help. Let's see. If there's a 7 up here, I would need a 2 over here, but that seems okay. One of these two is a 2. Oh, beautiful, beautiful. Okay, so Liz notices this cell sees all of 1, 2, 3, 4. Beautiful. Okay, so this is a naked single high. So those are high. These are low. So that automatically gives us, oops, the 8 and the 2. So we've got that. So that's not 2. This is 7, 8, 9. I still don't know what. Let's see. This is a 1 or a 4. Well, it's... Oh, I guess it could even be a 4, annoyingly. This is a 1 or a 4, of course. This, though, is not a 7. I can at least tell you that much, because 7 does not whisper 3. Oh, also, there's an 8 in this box. Fun fact. So this is not an 8. So that makes a 7-9 pair, which makes this an 8. See, it would have taken me way longer to see that if chat had not pointed it out. 2, 3, 4, 5, 6, 7, 8, 9. This one's not a 9 at the very least. This one I know nothing about, I don't think. Let's see. So one of these two is a 6. Let's see. Bounce the 8s. So the bet cell's not an 8. I can at least tell you that. Yeah, so the 8 is on this whisper somewhere. Just by virtue of that. Nicholas has an excellent question, which is where does 4 go in column 5? So it is ruled out by pencil marks of all of those cells. But also, I can't put a 4 in the middle of a whisper that's contained entirely in a box. So Nicholas's point is that we can sort these two out, and that is a beautiful point, 4 and 7. So these two aren't 7. So now I need a low here, and so that low must be a 2. So this is actually a 2-8 pair. And so this is the 7. So that makes that a 9. Makes this blue. It's a 2. These aren't 9 anymore. So they are 1, 7. And now the bet cell is a 3. Because we have the 2 in the box. So the bet cell confirmed to be a 3. This is not a 3. I did not do a good job of saying this is not a 3. I didn't do a good job that time either. 17th times the charm. This is not a 3. So this is high. So the way the bet cell works, and we'll have a bet cell in the next puzzle, is that I pick one cell at the beginning of each puzzle, and then we... everyone in chat who wishes to can make a guess as to what the value will turn out to be. And so that in this instance, a couple people ended up correctly guessing that this was a 3, including we always give BremSter credit whenever it's a 3, because BremSter is very consistent about his loyalty to 3s. Speaking of 3s, this 3 is going to resolve the entire rest of the puzzle, I believe. Because now if you look at it, now these two must be high. And these two must be low. So this is a 7, a 2, an 8, and a 3. And so now this has to be low, so those are both low. Those are both high. So this goes 1, 8, 2, 7. Bye, Franco. I should still be here in a few hours. So I will see you then. Okay, so now this can only be a 9. So we can go ahead and fill that in. So this is a 6 just by the box. So this cell is green. We finally have. That cell's green. So this cell's orange. This cell is blue. This cell is orange. And this cell is blue. And there we go. Yeah, I mean, I am very pro-coloring. As pro-coloring as it is possible to be, I believe. It's all about the colors. So this can't be a 7 anymore because it's next to a 3. So that's an 8. That's a 7. This is therefore a 6 because of the column. This is therefore a 7 or a 9, but it's not a 7, so it's a 9. That's a 7, which means that's a 1 and that's a 4. This column needs a 4. This column needs a 1. This row needs a 9. And there we go. Yes, you have to be careful not to accidentally finish the puzzle before you finish the coloring, because that is bad luck. Very nice puzzle. Very much appreciated that one, Mormagli. Okay, I am going to go to a way very briefly just to pull up the next puzzle, but I will be back in a minute or so. So I will see you all shortly. I've got to pull up Jesper's puzzle. Be right back. Oops, sorry, I should be in Penpa mode. Sorry about that. Welcome back. Someone asked how often I stream. I stream Wednesdays and Saturdays. So usually my stream starts about 3 hours ago and then lasts until about 5 hours from now. That is my approximate Wednesday streaming time. You can check they're scheduled on the stream if you want. And then we post like a puzzle a week, usually, sometimes more than one. The puzzle of the week is not super well named. It is the puzzle of the sometimes. And I also have a math channel. Yes, Directionary is correct. I also have a math channel. Yeah, having the next one scheduled would be good so people can see YouTube convert it to their time zone. Alrighty, so one of the things I do for those of you who support the channel is that I always let the people who support the channel as windmills or turbines, I let them vote on what puzzle they'd most like to see. This week, this is the puzzle they would most like to see. So this is voted on by Woofers, Ken LaRoe, Doomdiat, and David Ratner from chat. So thank you to all of you for your support, and so this is dedicated to you. So let's see. So we're going to have to read the rules carefully to this one. So I am mildly terrified of this puzzle because the last Jesper puzzle I did, I should say, is one of my favorite puzzles I've ever done on the channel. But it was rated as being 4 stars of difficulty, and it was probably the hardest puzzle I've ever done on the channel. So this is a 5-star Jesper puzzle. So we get to see how that goes. Let's read the rules carefully. So we're going to divide the grid into regions. So this is going to be a chaos construction. So we need every row, column, box to have the digits 1 through 9 once each. We're going to shade some cells, and we're going to need to meet the following conditions for shaded cells. The shaded cells are connected. The unshaded cells are connected. No 2x2 is either shaded or unshaded. It's some mix. And each region is either fully shaded or fully unshaded. So that is lesson 1. And then lesson 2 is the digit in a cell with one or more arrows is equal to the number of shaded cells that appear in the indicated directions combined. Not all possible arrows are given. So, for example, in this example puzzle, which I need to move myself for you to be able to see. Okay, the rules of this are very straightforward, at least. This 2, for example, the 2 is pointing towards these 2 shaded cells, and so therefore it is a 2. The 3 is pointing towards these 3 shaded cells, so it is a 3. This 3 is pointing towards those 3 shaded cells, so it's a 3. And so on. And notice that in this case, this is a 6x6 example. So they have all been... They've all been partitioned into sets of the digits 1 through 6, so these are the regions, and every region's either all shaded or all unshaded. And yeah, the clue itself is not in the direction of the arrow, so it does not count itself. Okay, and so here is going to be our puzzle. Let's see, it's going to take me a second to figure out exactly how to adjust this on screen. There we go. I don't know why the first time it loaded, it didn't load the right way, but the second time it loaded, it did load the right way, although this is obviously not the correct way to have this displayed on screen. One moment. So I can probably, let's see, there's a resize button. One moment, let me attempt the resize button. Display size, let's try that. Okay, so how is that? That actually looks not bad. I think I can work with that. Alrighty. So... alrighty. So let's work our way through this. So... the first thing in these is usually look for arrows that can only be so large. So, for example, this one can only be a 1, 2, or a 3 because it points at these 3 cells only. This one can only be 1, 2, 3, or 4. This is just my experience with puzzles with arrows that count things, is look for the arrows that can only be mildly large. One presumes this one's going to be rather large, but who knows? Row 8, column 3. Yeah, this one's going to presumably be large, but I don't know that I can put any constraints on it immediately. This one, though, this can only be at most 4. Yes, excellent from Nicholas. This cell can only be from 0 to 16. Hey, Jessica, welcome. Showing off your fancy green screen name and your windmill. Okay, so now, given that that didn't seem to do anything, the next thing to look at is for 2 arrows that count almost exactly the same thing. So these 2 arrows count almost exactly the same thing, except for these 2 cells. So one of these 2 cells, at least, is shaded. Oh, that's right, I need a bet cell. One moment, I need to put in a bet cell. We're going to guess that this is a good bet cell. So this is the bet cell for the puzzle. Okay, so because this cell and this cell count almost the same things, they need to be different. So one of these 2 is shaded. So I'm going to mark that by putting a, I think I'm going to put a tiny dot here on the edge to say one of these two is shaded, maybe, possibly, if it will let me do that. Or maybe I want... No, I don't think I could do that. I think I need to do the shape. Sorry, I lost my display already. So one moment. I need to pull up my display panel, I think. Maybe not. I may have to give up on that. Oh, there we go. Panel on. There we go. I was the silly one who thought, oh, I'm not going to use this, and then immediately wanted to put a dot right there. Should be extra small. It doesn't need to be that big. Okay. So this dot is my, again, notation for the fact that I know one of these two is shaded. At least. It could be that they're both shaded, but at least one of them is definitely shaded, and so that is the first and so far only thing that I know about the shading. But I'd like to see other things. So the same thing I can do, actually, and this is going to be way better, between these two arrows. These two arrows, again, almost count the same thing, except for these two cells, which means that because they're different, one of these two has to be shaded. And now that's particularly relevant for a yin-yang puzzle. And the reason for that is because in a yin-yang puzzle, if you look at the... That's not the mode I meant to be in. If you look at the border in a yin-yang puzzle, it always consists of a whole bunch of green in one piece, followed by a whole bunch of gray in the other. But there's always only one contiguous piece of green and one contiguous piece of gray. So the fact that one of these is gray says that if I can identify similar cells, I'll be able to sort of chase that gray all the way around the edge. So that is the upshot there. So I'm very interested in shaded and unshaded cells on the border of the grid. Let's see. Where else can I find something interesting? These two arrows, not quite as good. That only tells me 3 things. Let's see. Garion is suggesting, and I think this is a good idea, that thinking about where the high digits go is a good idea. I'm going to, by the way, just for people who come in, I'm going to change my shape here slightly. For one of these things is shaded, I'm going to make it this dot, just so that no one who comes in thinks that these are actually Kropke dots, because they're definitely not. All right, so Garion's point is, hey, I need to put a 9, an 8, a 7, and a 6 into this row. So some of these digits have to be quite large, just by virtue of that. Now, I could hide the 9 and the 8 over here, and I could put the 7 here, say. And this digit being large doesn't really tell us anything. But it's eventually going to force there to be lots of shading to think about. Now, I suppose... I know there's some shading in this column. I don't know how much, but I know there's some. Oh, okay. So here's an interesting thing to think about. These two are interesting. Because they need to have... different total numbers, which means we're going to want to have some down here, but we also know one of these is shaded, and this is already getting sort of complicated when we know the shaded cells on the border are connected. Zenetics, the reason why this is stream 55.5 is that Simon on Cracking the Cryptic today did MIA as a live stream is not the word for it, but I've forgotten feature or something. And so we paused to go watch that. Premiere, there we go. Okay, so let's see. Jay Dyer says the top row can't all be shaded because of the arrows pointing at row 1, column 5. Good point. Okay. So if this whole row was shaded, these two arrows would both be a 5. So there is a break in the shading in row 1. That is a beautiful spot, Jay. I don't have even the slightest clue how I would begin to pencil mark that. But there's a break in the shading somewhere in row 1. So there can only possibly be one more break in the shading. And so, again, there's a break in the shading somewhere here, and there has to be some shaded stuff in this column. So I think that means that these at least are shaded. Actually, I think that means that these at least are shaded, right? Because there's a break in the shading here. I know one of these two is shaded. And I know one of these is shaded. And so I can't connect the fact that one of these two and all of these gajillion are shaded. I can't connect them around the outside of the grid because that would break this cell by 1,000,000. So I have to connect them through this corner. If it goes around the other way, this cell has a value of 17 or something, which is not possible. So I have to connect them the short way around, which means at the very least, I think these cells are shaded. So let's go into shaded, and let's make shaded purple, like that. Oh, it could go the long way, but only... Okay, let's check that. Okay, so it could go... We're connecting something here to something here. And so the something over here could be, this is Jay's point, it could go there. So the question is, if we did something like this, the question is if that's possible. Because now this digit's actually only a 9. So this digit's actually okay. And then this doesn't break because one of these two is shaded. I think, unfortunately, this is plausible. Yeah, I don't see any reason why not. Garion has a smart observation, which is that this cell always needs to see a break. Because if it doesn't see a break, it's either a 0 or a number that's too large. Okay, so Jay's actually arguing it actually can't go the other way. No, I think it's fine. Isn't, like, even this would be fine, right? Because this arrow is a 2 and this arrow is a 1. Oh, but we need shaded cells in column 9. Got it. Okay. So, yeah, so we can't wrap this direction. Because if we wrap this direction, we can't go all the way through here, and so we'd end up with nothing in column 9. Because we know that there's a break in row 1. So if we start here and go this way, we actually have to make it all the way over to column 9, to at least here. And then we've super broken this cell. Okay, great observation by Jay. So actually, we need to go all the way over here, and we need to make it at least to here. All of these need to be shaded. At least. which means that this is an 8 or a 9. Oh, but it tells us this cell, which means that this cell is 1, 2, 3, 4, 5, 6. It tells us this cell is a 6. And so we get our digit. And so we have, if you are new to the channel, we have our digit dancing penguin, who's going to do the 6 dance for us, to dance for the first digit of the channel. The official channel mascot and digit dancer. We also have a color penguin, but he lives with Tristan downstairs in the other region. 6 dance. Woohoo! Thank you, Zach. Much appreciated. Now, chat has pointed out that actually Zach gets even more credit because this cell now is a 7. This cell now is a 5. Let's see. So those are also available. This is at most 1 more high, because otherwise this becomes more than 9. So this is a 1 or a 2 only. Oops, sorry, I meant to do center mark. 1 or 2 only. This is a 6 or a 7 only. Yes, so most of column 1 now can't be shaded. So none of these cells can be shaded. So we can go ahead and we can unshade those. That is a good point. That is well worth our colored pencils to use. So these are all now definitely unshaded. Yeah, this is at most 4, Matthew points out. So this is 2, 3, or 4. Can unshade. Oh, this is unshaded because I can't make a 2x2, and this is unshaded because I can't make a 2x2. It's an important time to remember that the rules exist. So these are green each. There are no 2x2s in this, at least in this yin-yang puzzle. Are there no 2x2s in any yin-yang puzzle? It's possible that that is a standard yin-yang rule. Let's see. Chat confirms that that is the standard yin-yang rule. So if this is purple, does anything go horribly wrong with the universe? Not that I can immediately see. Row 7, column 7. Cannot be 4 anymore. I don't think this is row... Oh, so row 7, column 3. So I misread what you wrote, but then I looked at the right cell anyway. Can't be 4 anymore, because now this is unshaded. Let's see. Okay. What is the absolute... Now these two actually end up being rather similar. I can't actually put all that many purple cells in this row, because this row can't have 2 consecutive purple cells. And so because there can't be consecutive purple cells, I can fit at most 4 purple cells here. So this is a 1, 2, 3, or 4. And this one, likewise, could be at most 4 as well. Wait, if this is also at most 4, they can't be the same. Oh, this would be 4 in the universe. Wait. What's the universe where this is 4? There's no way that this is 4 where this is... Ugh. I feel like I should be able to rule 4 out of this cell. Yeah, if this is 4, that's 3. Maybe it's this one. If this is 4... Oh, it's this one. This one can't be 4. Because if this is 4, then this one is definitely 4. Okay, that I was looking at it the wrong direction. If this cell is a 4, then that's saying that there are 3 shaded cells over here. So that would mean that this sees at least 2 shaded cells in here, plus 1 here. Oh, maybe that's okay. Never mind. Oh, okay. Sorry. People have a much nicer way to look at this. If this cell is unshaded, sorry, no. If this cell is shaded, then we have a big problem. Okay. We got there. Okay. If this cell is shaded, now its total is 1 plus the number of shaded cells in here. Because it's also seeing that one. But this one's total is also 1 plus the number of shaded cells in here, and so they are the same. So that does not work. So this cell is not shaded. So that cell is unshaded, which now means that this is an 8. Sorry, normal, it's an 8. Which means that this cell's a 1. This cell can't be a 1. The bots must have been on Simon's stream today, and so decided to head over. That is my theory. Okay, this can no longer be... Oh, no, sorry, never mind. Okay, now what's the most this can be? Right, now the most I can fit in here as far as shaded cells is 3, because, again, I can't put shaded cells consecutive to each other. So this is no longer able to be 4. This is now at most 4. Oh, but this can't be anywhere near 4 either, because this is actually at most 3. Oh yeah, this cell, now because of the way this cell is always 1 more than this cell. That is a good way to look at it. Yeah, so there is a relationship between these 2 cells, I think. So this is confusing. So there's this relationship where if none of these 3 cells were shaded, these 2 would be... Sorry, this would be 1 more than that. Oh, boy. Okay, so let's just go through Garian's way of saying it. This can't be 1. What happens if this is 1? Well, there's a shaded cell over here in exactly one of them. So now that shaded cell can't be over here, because if there was, this would also be a 1. So that shaded cell is in here, which makes this a 1, this a 2. because it sees this one and this one, and then a shaded cell back here, except now this isn't a 1 anymore, so that doesn't work. So this can't be a 1. So we have to sort of somehow think of all of these things as being entangled together. I mean, they are all entangled together. But they're in particular, not all of these numbers can be less than 3. One of these numbers is at least 3. So there have to be 3 total shaded cells at least in this row. Garian points out now, eliminating 1 from this is tantamount to eliminating 2 from this cell because definitionally almost this cell is 1 more than this cell. It's that cell more. So I agree with that. In the world where this is a 3, both of these are shaded. And so this is a 2. So if this cell's a 3, these are the 2 shaded cells, but then this cell's also a 3. That doesn't work. So the world where this is a 3 does not make sense, and I see Garian is also suggesting the same thing. So there is 1 or 2. In the world where this is a 1, that cell is shaded, and that cell is shaded, and those are the only shaded cells in the row. Because in the world where this is a 1, it unshades all of these. So one of these 2 cells is shaded, but that doesn't work because then that does not allow this to be a 3 or a 4. So this can't actually be a 1. It is a 2. So that's a 2, which then means that's a 3, which then means that's a 4. So now we have to look at this being a 4. There's lots of ways, unfortunately, for this to be a 4. Unfortunately. So there's definitely a shaded cell over here. Okay, so one of these 3... Okay, no. One of these 3 cells is shaded. And so since one of these 3 cells is shaded, that means 2 of these 3 cells are shaded. Well, we know which 2. It has to be these 2. That's the way to do it. So these 2 are shaded. So therefore, by the no 2 by 2 rule, these 2 are unshaded. Wait, did I do that? Did I math that wrong? Sorry. The non-Kropke cells are just my way of noting I know at least one of these 2 is shaded. I mean, in this case, this one's now redundant, but one of these 2 I know is shaded. That's what it means. So I said one of these is shaded? That's right. One of these is shaded. Oh, let's go back. So people want me to go back further. Okay. So people want me to go back to here. So if this is a 1, these are all unshaded. So I'm going to go through this again. If this is a 1, let's just write it in. If this is a 1, all of these are unshaded. So now this has to be a 2. Right, and then I can shade both of those. Okay, you're right. So yeah, completely right. That works. So I don't think I can get rid of that. Oh, sorry. I think I can get rid of that. Yep. Completely right. That could be a 1. just not counting things correctly, which is bound to happen with this kind of puzzle. All right. Okay, so there are some people in chat claiming you always need to shade 2 of these 3 cells, so these 2 cells are always shaded. Let's see if I can convince myself that these 2 cells are always shaded. Oh, this being 3 is still... that still doesn't work. Oh, I think I still believe this can't be 2. I did argue that before that this can't be 3, but let's do that again. If this is 3, these 2 are shaded in order to get to 3. It's the only way that works. This is 2, which means nothing else in this row is shaded. It already sees 2, but now that means this is also 3. That definitely does not work. So this is not a 3. So J40 is attempting to argue that 2 of these 3 cells have to be shaded, because if only one of these 3 cells is shaded, then that means that this cell has the same value as this cell. Unless none of them are shaded. But if none of these are shaded, let's first argue. If none of these are shaded, then this cell and this cell have the same value. So there's at least one shaded cell in here. And right. And if only... so there's at least one shaded cell by looking at these 2 cells. And there can't be only one, because if there's only one, then one of these is shaded. And so this cell is giving me 1 plus however many cells are shaded here. No, 2 plus however many cells are shaded here. But this cell is giving me 1 plus however many cells are shaded here. And this cell is also giving me 1 plus however many cells are shaded here. So in that world, these 2 become the same. So that makes sense. So it's these 2 are the same. If there's one shaded cell over here, these 2 are the same, because they're both the number of shaded cells in here plus 1. So I need 2 shaded cells out of these 3. That can only happen if it looks like that. So that's shaded and that's shaded. That's unshaded and that's unshaded. Okay. I believe that. And I do know one of these 2 has to be shaded, right? No, I don't think I do. Maybe I... green now, Jay points out, green has to connect, so I can come out here, like that. And so now, that is going to say, okay, now this can't be a 3 either. So this is now only a 1 or a 2, depending on whether this cell is shaded or not. So if none of these are shaded, then this is a 1, this is a 2, and this is a 3. That seems plausible. If one of these is shaded, then this is a 2, and then a 3, and then a 4. Okay. Let's see. I can try and draw lines here to indicate I know these 2 are in the same region, just to start keeping track of that. Okay. So this cell's at least a 4, for whatever it's worth. I agree this cell's at most 6. So it's not 1. It could be 2, 3, 4. It's not 5. It could be 6. It's not great, but it's not terrible. It's worth, I think, thinking about. I was thinking I shouldn't think about it, but I think I do actually have to think about it. Okay. Oh, these are already... Oh, if this cell is shaded, these two have the same value. Right? Because if this cell is shaded, they're just counting the number of cells in here and adding 1 to it. So this cell has to be unshaded. In order to make that work. So these two differ by 1. This one's the bigger one. So now that actually does a bunch of 2x2ing. It shades those two cells. So that means that this is a 2 now. I can just do it. It's a 2. So this isn't a 2. I can't have a checkerboard because of connectivity. I believe. I have to think about this for a second. Yeah, if I have a checkerboard, it would break connectivity. Because I would have to connect... Imagine this cell were purple. I would have to connect green around here, but in connecting green around here, then I would sever the two purples. Or if I tried to connect purple around here, I would sever the two greens. So yeah, so there is a 2x2 principle in effect. So that is green. So that is a worthwhile endeavor. Row 4, column 2 is known. Yes, it is. This cell now is a 4. So that's not a 4. I do know one of these two is shaded. I don't immediately see what to do with the information that one of these is shaded. I'm going to continue my my lining. These all have to be in the same region, so that's definitely in the region. That's definitely in the region. So we're slowly assembling a region here that's currently at size 4, 5, 6. So we're getting there. And now I know one of these two is shaded, but I don't think I know which of these two is shaded or if both are shaded yet. Row 8, column 2 is 5 or 6. 2. Okay, yes. So this already sees 2, but it can't be a 2 because in all possibilities, both 2 and 3 are accounted for among these 3 cells. There's a virtual 2-3 pair among these 3 cells. So this is at least 4, but it's not 4. So it is at least 5, but it is also at most 1, 2, 3, 4, 5, 6. It's also at most 6. So this is a 5 or a 6. So actually, there's lots more purple to be had up here. Oh, and we can look at this same cell, or we can look at the cell up here, Matthew points out. This cell actually already sees 4, but it can't be a 4. So this is either a 5 or a 6 as well. So this is a 5-6 pair, which makes this a 7. And that being a 7 makes this purple. Makes this not 2. It's at least 3 now. This can't be a 6 anymore. There aren't 6 cells for it to see. There are only 5, so this can't be a 6 anymore. So this is now a 3-4 pair. For what it's worth. So I can write in the values of the rest of the cells, because these are not 1. There is a 2. There's not a 3, a 4, or a 5. There is a 6. There's not a 7. There is an 8 and a 9. I know that one's not 9. I know this one's not 2. Thank you, Kajito. This one also can't be 8, because being 8 would require all of these be shaded, and one of them is not. Good point to Ambrose there. So this is a 2 or a 6 only. Okay, so is what I know that one of these two is shaded? I'm trying to figure out what the fact that these 5 and 6 are different. So the 5 and 6 see in common these cells. Okay. So the 5 and 6 see in common these cells. Well, that means this one has to be the one that's a 6. Because this one is however many shaded cells there are here, plus however many shaded cells there are here. Well, that means that this cell in row 2, column 2, it's definitionally bigger than the one that's here, or at least the same size. So this is the 6 and that's the 5. And now once this is a 6, actually, we know what they are. Namely, these are the ones that are shaded. And now the 5, who knows exactly what happens with the 5. I can unshape these two cells now, because that's no longer relevant. But that works out. Yeah, one of these two is shaded. Don't think I know which one yet. I certainly have a region that's forming at least this far. Oh, that's not the right tool. That's the right tool. These both being 1, 2, 3 is interesting. Okay. Can this be 4 still? In order for this to be a 4, I would need to make these two both shaded and that shaded, which actually looks like a very yin-yang-y sort of arrangement. So maybe that can still be a 4. Can't be bigger than 4, but unfortunately I already knew it couldn't be bigger than 4. Let's see. Carl, I think, thinks that I'm wrong. Carl, I think, sees something wrong with this arrangement of 4. But this looks plausible to me, but I'm not sure. Okay. Oh, this can't be a 6 because there's a 6 in the column. Which means there's a whole lot of shading going on in this column. Because this sees 2 over here. It needs to see at least 6 shaded cells in this string. And there are 1, 2, 3, 4, 5, 6, 7, 8 cells there. So let's see. Jay says, how do you make the 5 in column 2? Okay. So if this is a 4, this is forced for the column. But now this 5 in column 2 is 1, 2, 3, 4. I can't shade this cell, so I would have to shade this cell. That's now 5 for this. Except that now breaks because this cell is now also a 4. And so that repeats the 4. Okay. Hate that, but I'll live. So this isn't a 4. So this is a 3. And that's a 4. Which means that this is shaded in order to make that work. I'm going to guess there's an easier way to spot that I did not see. But that is a several steps long chain. But it is cool that it works out that way. It's unshaded. Because of the 5. 1, 2, 3, 4, 5. The 5's already satisfied. So that is unshaded. Because this 5 is now satisfied. Is the point. Okay. This cell is slowly getting impinged upon because it's only seeing green so far. So it's actually now at most 5 for whatever that's worth. Let's see. Okay, so Jay is suggesting I fill out options here. So this is at least 4. Could probably be 4. Can't be 5. It could be 6. It can't be 7. It could be 8 or 9. Actually, I know how many cells it sees up here, don't I? I know it sees 2 cells up here because of this 3. No, I know it sees 3 cells up here because of this 3. So actually, I could do better. In this direction, this thing sees 3 cells exactly. 4, 5, 6, 7. So this is definitely an 8 or a 9. And I think that's going to sort out. I think that's going to sort out what happens here because it sees exactly 3 up here, 4, 5, 6, 7. It needs to see and can in fact see at most 1 more. So this is an 8, and because of that, we now know what happens with these numbers because now there needs to be a cell that's shaded in here. So therefore, that's a 2, that's a 3, that's a 4. I don't think that immediately tells me exactly what the shading in here looks like, but I know one of these is shaded, so I can bring back my my little fancy circle and say one of those is shaded. Uh, uh, okay, row 6, column 2 is at most 6. But it's not 4 or 5 or 6, so it is 1, 2, or 3 only. And now, notably, that actually does an elimination over here, because this cell is 1 higher than this one, so therefore this one can't be 5. Oh, also, this one can't be 1. Sorry, no, this one can't be 1, because this cell is 1 higher than that one. So this is the bigger. Sorry, so wait, no. No. This one can't be 1, because it sees that and needs to see another cell, right? Oh, crap. No. Yeah. Wait. Okay. I need to rethink about this. I think I did this wrong. Okay. Let's put back the 5. Okay. What's the relationship between these two? This one is 1 bigger, right? The one that currently is pencil marked 1, 2, 3 is the one that's bigger, because it sees this cell. And so, in fact, actually, this one can't be 3, 4, or 5. It can only be 1 or 2. And this one, being the bigger one, can't be 1. It's only 2 or 3. So that that resolves that, I believe. Well, I mean, it doesn't resolve it, but it at least gives us that much information. Okay, I was just being pessimistic and assuming that it was going to work out the other way, but in fact, it did not. All right. These two are definitely in the same region. These two are definitely in the same region. These digits I should write in. They are a 1. We've got a 2. We've got a 3, 4, 5. We need a 6. We've got a 7. We need a 9. That one's not 6. Makes that 1 or 9. It's not as instructive as I'd hoped, but what are you going to do? Let's see. Okay. Good point from Ben. If this cell is shaded, I need to get one more shaded cell. It can only go there, but now I've created a checkerboard, so that does not work. So this cell can never be shaded. Great spot to Ben. This is an unshaded cell, which now actually means that this cell, if I look at it, actually can't be 3. It can only be 1 or 2. So in all universes, I believe this cell is shaded. Maybe not. Maybe I'm wrong. I think that might be bad logic. So it could be these two that are shaded. Oh, but it can't be these two that are shaded. Yeah, I was right. These can't be shaded because that creates a checkerboard. So this is always shaded. Thank you for catching that. I was going to completely let that go and miss that. I think Ambrose's comment was withdrawn, Nicholas. So yeah, one of those two is purple. Let's see, if this is green, it does create this whole thing. Oh, it can't get a 6 here because there's a 6 in the column. Okay, so this giant region is currently at 6 cells. So, but there's lots of places it could get a 6. It could continue over here and get the 6, but it could also come get a 6 up here somewhere or there. I don't think this is decisive at the moment. I think it could be decisive at a later date and time. Okay. There's at least 2. What's the most shaded cells I could put here? Well, I can shade one of these 2 cells, so I could shade exactly these cells. So there's at most 3 shaded cells in here, which means that this is at least 2 and at most 5. So this is 2, 3, 4, 5. And this is not a 3. So this is 2, 4, or 5. Again, using the fact that I can't shade 2 consecutive cells out of this string of things. If this was 2, that seems like it would be really problematic, but I don't know. I've seen stranger things. This is a 1 that unshades that cell. Have a good evening, Ambrose. There's at least 1 shaded cell in here. There are something like 4 or 5 shaded cells in here. None of that looks useful. I can see where the problem is going to be, because this puzzle has not been too difficult so far, but we are almost done with the clues of the puzzle, and we are nowhere near done with the actual puzzle. Okay, I want to pencil mark this cell. So it's not 1, 2. It could be 3. It's not 4. I think it could be 5. Let's see. 6 or 7, maybe? But most of the values that are possible for this cell are quite large. Row 2, column 3 gets shaded. Where does this region get its 8? Goes, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, wow, that's a good point. Okay. So Josh has an excellent point that if this is shaded, now this region here has been lopped off of getting an 8. So I know there's a region that starts up here with the 1 and the 6 in this universe, and then it continues on down. And then its only optionality is it could turn here, but that also leads to a dead end where it runs out of cells. So this cell can't be shaded. That is very clever. So this has to be unshaded, which means this does have to be shaded. Green is connected, so that's shaded. So now this digit is known to be a 1. So this is not a 1. Very, very good. Oh, it certainly can't be the big one. It can't be 7, because that would isolate the green cells. So this is not 7. Notably, the exact same argument Garian notices, and SPQ notices, argues that this has to be unshaded, because if this is shaded, now this region has all of these cells in it. That is already 8, and none of those cells can get an 8, and there's no... Well, if this was shaded, it couldn't get an 8 there, because that couldn't be part of it, so it would be lost. So this is also unshaded. So now that's putting a lot of pressure on this total, because now this total is 1, 2, and then it's at most 4 now. So that is 2 or 4. 2 seems very unlikely, but who knows? I've been wrong before. Oh, okay. Now I see Matthew's point. So if this was a 6, that would mean I needed to shade 4 of these 5 cells. But also one of these 2 cells is shaded. So if it was this one that was shaded, I would need to unshade this cell. And I'd also need to unshade one of these cells. But that's too many. If it was this cell that was shaded, I would need to unshade that cell, but also one of these cells, and that's too many. So it is not possible that this is a 6. That's complicated, but I agree, it's not a 6. Good point. So SPQ has seen the commonality that this is either 2, in which case there are no shaded cells here, or this is 4, in which case both of these are shaded. In all cases, this cell is unshaded. Beautiful observation. And so now this arrow can only be a 2. And in order to be a 2, I still have to purplify this cell. Now, right. Now, it actually can't be a 4. Because if this was a 4, these would both be shaded. And if these are both shaded, I create a huge problem where either I put a green here or a green here, creating a checkerboard, or I make these purple as well, in which case I've isolated that green. So this actually is a 2. Which means that these actually are green against my expectation. But what can you do? So now, this is a region, and we can finish off our first region, and we get a digit out of finishing off our first region. Sorry, I should make this thicker. This is a region. Doop-doop. That's our first region, and so this region needs a 1, and that 1 goes here. And so this is a 2, And that's a 3 by Sudoku. This is not a 2. Okay. So there are 2 shaded cells in here. I don't know if that immediately is going to resolve the world. Oh, this is also not a 2. Beautiful spot by Nicholas. And so now this is the 2. And that's pretty nice. This isn't a 1 anymore. So yeah, so these are 6, 8, 9. I mean, one of these two is purple. Has to get out somehow. And purple only glances this column. It only gets one more purple cell in this column. This can't be the purple cell in the column. If this is the only purple cell in column 5, then the stuff over in columns 1 through 4 can't connect to the stuff over in columns... Oh, no, that's not true. Sorry, I was going to say something that's wrong, but it could connect, because it could connect through here. Never mind. Let's see. Okay, being asked about 2 in row 9. Not there, not there, not there, not there, not there, not there. Ah, so the 2 in row 9 goes here. Okay, and that's going to have a huge consequence because now this 2 is locked out of this region. So I can draw in this edge because this region now already has a 2. So it cannot come up here, which means that this region has to grow up here. So that cell becomes purple. Because, spoiler, it is not done yet if it only has 1 digits. Okay, I'm going to take a moment to fill in all of the edges just because aesthetics matter. Da 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 da. Da 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 da. Okay, we have now done much shading. Okay, that does force, speaking of things, that does force this to come out here. So this region, whatever it is, has to come out that way. I should fill in a couple places. So one place I should fill in is I should fill in this column. So this column needs a 1. It's got a 2, 3, 4, 5, 6, 7. It needs an 8 and a 9 as well. This can't be an 8, owing to the fact that there's already an 8 in this region, whatever this region looks like. Oh, in fact, this region has to keep growing out this way now. Because it's not done. 1, 2, 3, 4, 5, 6, 7. It can't grow up, so it's got to keep growing over to here. So we've got actually much more going on in this region now. So this region's actually starting to look a little bit defined. This region, of course, goes up. Let's see. Okay. That is a good point. So Jay has observed, and this is correct, that actually this region and this region can never merge. If they did merge, they would take all of these cells and then they would need an 8 to finish, which is not possible. So because they're separate regions, they both have to escape, meaning that this region's going to have to take this cell, and this region's going to have to take this cell. Now, even if this took 1, 2, 3, 4, 5, 6, 7, it still needs to take these. So all of these become part of one omega region of size 7. So it takes at most 2 cells up here. So this region always takes this cell. Now, that argument actually gives us that this cell's a 5, which is gorgeous. And so that means I need to fit 2 more shaded cells in here. Gorgeous spot, by the way, Jay. Really impressed by that one. I'm going to fill in these for digits for the region. I need a 1. I've got a 2, 3. I need a... No, I don't need a 4. I've got a 4, 5. I need a 6, 7. I've got an 8, and I need a 9. So that one's not a 1. Maybe that was not useful. Yes, we can continue this line, because this line now gets at most 2 cells down here. And so that's at most 6. So it needs to go 1, 2. It needs to go at least that far. Okay. Now, if this is purple, that's okay, actually, I think. I mean, there's lots of places it could get an 8, aren't there? It's just over here somewhere. Go over there, whatever. Let's see. Where's the 2 in this row? Do I know that? Could be there. Could be there, annoyingly. Not there. Not there. Could be there. Not there. Okay, so there's a few places the 2 could be. I can go ahead and put a line in here. Not that I think it does an enormous amount, but, it does technically not nothing, I suppose. Row 7, column 2. Yes, these 2 cells have to appear in good point from Garion. These 2 cells need to appear in row 9. The only places they can do so are here. So these digits are from 1, 5, 9. That one's not a 1. So it is a 5 or a 9. Let's see, where is it? This is the column where I've got the bothersome 2. Because there's only 1 more shaded cell out of all of these. I don't know that there is a bottom right region. Maybe if I think very hard about 6s, I'll know there's a bottom right region. But I don't presently know it. This isn't a region. We have no reason to suspect that this is a region. It could be multiple regions strung together in all kinds of ways. Unless it's marked, or there is a good reason otherwise, we don't know that just because there's some similarly colored cells together that they're part of a region. If row 4, column 5 is purple, you'd get a checkerboard problem in row 3 and row 3, column 4. And row 3, column 5. Okay, so if this is purple, then it would immediately turn these 2 green. And then this cell, because of the 2x2, could not be green, so it would be purple, and that would give us a checkerboard. Yep. Okay, so this is a very nice point to Carl, I think that was. This is green. We did do the Sudoku 1-2s. I think it was not helpful. The 2s, we need a 2 here. In this row, we get a 2 and 2. There are 3 2s left to place, which are in... Are there 3? Maybe there's only 2. Are these the only places left for 2s? I thought there was one more row or column of 2s. We've got 1, 2, 3, 4, 5, 6, 7. Nope. Okay, there is only an X-wing of 2s. I'm willing to corner mark that. There are 2 2s left. So we could ask questions like, one of those 2s is green. Is the other 2 green or whatever? But I guess this 2 we don't know the color of yet even. So maybe we can't quite do that yet. But I think at some point we're going to need to count the number of digits of each color there are, because there will be the same number of digits of each color. And so, like, once we have colored all of one particular digit, we're going to know exactly what the disposition of regions are. Let's see. Matthews is row 7, column 5. And 6 can't both be shaded because they would break row 8 if both of these were shaded. This would have to go green, green. Yeah, so, okay, I agree. These can't both be shaded because then that would require this to sort of glug its way out. And similarly, these can't both be shaded because that would require... Oh, wait, maybe that's not true. Maybe these could both be shaded, because this would escape that way, but that's okay. But these 2... Wait, why can't these both be shaded? The green has to escape, but why can't the green escape? I'm not sure. Oh, that's right, because there's a shaded cell in row 8. Right, one of these 2 is shaded. So if these are both shaded, then this couldn't be shaded and that couldn't be shaded. And that's the problem. Right, okay. So these aren't both shaded. And I do actually get the same thing. These aren't both shaded either, because I would need to shade one of these, and either way I've lopped this off. So actually, what that means is one of these 2 is shaded and one of these 2 is shaded. So we can go back to our little magic dots. It was a cool observation, Matthew. Row 6, column 4. Sorry, someone was saying something about row 6, column 4. Can't be green. I'm missing the connection, I think. Row 7, column 7 must be shaded, because if not, the rest of the column must be shaded, and that traps row 8, column 8. Okay, let's double check that. So if this is shaded, then I can't shade... Yeah, this clue is telling us we should remember that we need to shade at least 6 cells out of these. So we need to shade at least 5 of these. And there are a total of 6 of them. Can I just write in that this is an 8? I can't possibly shade all of these, can I? No, I'm wrong. I need to color at least 4 of these. No. I'm right? That's 3. So yeah, I need at least 5 more. I need to color at least 5 of these 6. I can't possibly color all 6 of these 6, can I? Is that obviously broken? Maybe it's not obviously broken, which would be horrible. It's probably not obviously broken. But I'm still trying to parse out Afraid Not's point about what happens if this is, I've forgotten now if it's shaded or if it's unshaded. If it's not shaded. Yeah, I don't quite see this. So if this is unshaded, this is shaded. Yeah, I guess if this is I guess the point is if this is unshaded, all of this is shaded and that's shaded. Okay, I got it. Okay. So because 5 of these 6 cells at least are shaded, if this is unshaded, then all of this is shaded, owing to this clue, but also one of these 2 is shaded, so that's shaded, and then we trap the 3. Okay, nice spot. Okay, so this is not, so this is shaded, and so this is not shaded, is the punchline there. Shape, we can get rid of that. Same applies to row 3, column 7. If this was unshaded, I'd have to shade the rest of the column. The other one is green because we proved these couldn't both be shaded. In this case, the dot is slightly confusing. In this case, the dot is telling us I actually know one of these 2 is shaded because of the 5 in the row. But you're completely right. I didn't at all justify it other than that I'd previously put the symbol there to remind me of that. Okay. So it's a completely minuscule point. But these 2... Oh, no, this is not a minuscule point at all. Green is, these 2 are part of a region that can't get out on the left, so it's going to have to get out up here. So this cell has to be green. Because one of these 2 is shaded, whichever one it is, it's going to block this in from going out this direction. It's going to have to come out this direction. So that's going to go up like that. Now we're really hurting to get our 2 shaded cells in here. We're going to have to be very, very careful. Okay, let me go back to what SPQ was saying. If row 3, column 7 is unshaded, then I have to shade all of this. And now because this is unshaded, this cell is shaded. And so now all of these are shaded. That's by the 2x2 rule. As soon as this is unshaded, it shades this cell, but then the clue forces all of that, and now we've isolated the screen. Okay, excellent point. I never would have seen that, but I agree. This can't be shaded. Wait, sorry. Has to be shaded, not can't be shaded. Sorry, I did that backwards. I argued it out loud, but no, it has to be shaded, not can't be shaded. if row 6, column 4 is green, then these are both purple. And now the rest of column 5 is green. And now this region is isolated. Okay. Okay. This is another really long chain, but I can explain it. If this is unshaded, then now purple is going to escape over this direction. So in this universe, we're imagining this is green. These are both purple. But now I'm done my purples for column 5, and so all of this is green. But now I have this giant sea, this border of green trapping in this region. That does not work. So this cell must be shaded. Good spot. That was row 6, wasn't it? Oh, you were talking about this cell. Yeah, so if this cell, okay, your point is actually much simpler than the thing I just did. If this is green, it chases purple over here, but now purple is done. Because purple can't grow in the column, because there's only one more purple cell, and it can't grow to the right. So if this was green, then this purple region would get trapped. So this is purple. Okay, so that is so. Okay, and so now we can do a lot of regioning, because whatever purple cell is in this string, if there is a purple cell in here, is part of this. Wait, no, sorry. I don't agree with myself. Never mind. I don't think I agree with myself, at least. Now, sorry, I was looking in the wrong place. Now this is a region. That was the point that was being made, and that's going to give us the 2s. Because that cut off any other outlet of this. And so now the point is that this can't be a 2, so this is a 2, and this is a 2. That's not a 2. And we can fill in what these can be. They can be 1, but not, and then they can be 6, 7, 9. Which means that this digit is the 8 for the... No, this digit is the... I did not do that right. It's the 3. It's the 3 for the column. And this is the 1 for the region. I think I did that right eventually. But not, I'm sure, without making you all rightfully nervous that I was going to do something horrible. 6 in column 3. Not there. Could be there or there or there. Not there. I don't see any restriction on 6 in column 3, really. Why can't 6 in column 3 be here? Da. Row 6, column 5 can't be shaded. If this were shaded, it would make both of these unshaded, which would make this shaded. So if this is shaded, those two are unshaded. Oh, I'm on the wrong spot. Row 5, column 6. We're saying this can't be shaded. No, row 6, column 5. It said row 5, column 6 to start, right? We're talking about row 6, column 5 instead. Okay, row 6, column 5. This one. Saying this can't be shaded. If this is shaded, it unshades the things around it, of course. Unshades those. Shades this, which then shades that, which is too many. Okay. There may be a smarter way to see this, but what I'm seeing is if this is shaded, it then immediately unshades those two. Now, by our dottage, this gets shaded. So by the no checkerboards, that gets shaded, and now this clue is overflown. So that is not shaded. So it is green. I think Garion had a smarter way to see it, because Garion was saying it was breaking this clue, whereas I broke that clue. Is very believable. So one of these two is shaded. We can put our little shape down again, just to remind ourselves that one of these two needs to be shaded. Shading the bet cell would also create a checkerboard pattern. Let's see. If this is shaded, then this is unshaded by the thing down here. Okay, yeah. So yeah, if the bet cell is shaded, this is unshaded. So therefore, this is shaded. Wait, that is 5. So that's unshaded. Yeah, it sounded good until I actually tried to argue why it worked that way. Yeah, this is one shaded and one unshaded. people are claiming, by the way, that there are 5 purple and 4 green regions, which I think is probably true if you count, but I don't feel like making that argument unless I absolutely need to. Let's see. I probably want to like enter digits in here. 4, 5, 6, 7, 8, 9. See if I can get any free digits. That's not an 8. That's not a 5. That's not a 4. Maybe not. I was hoping that would be more restrictive. It was not. The problem with this region is that it can escape through, I guess, only through this hole now. It can't escape through there, but it could escape through over here, I believe. If it can't, that's new. Oh my god, is it not going to be able to escape because of the 2s? Oh, it could go down, but that's not nearly enough cells. No, it could do that. Probably does do that. Yeah, I think this is still plausible. It did not. The green was connected. This green connects. Oh no, I need a purple cell in here. That's right, I need a purple cell in here. I was forgetting that I need a purple cell in here. There's probably some smart way I can use the fact that I know that exactly one of each of these things is shaded together with connectivity to figure out what happens. So if this is shaded, that has to be shaded. It's unshaded. Unshaded. This unshaded. I don't know. This string of exactly one of these is shaded. I feel I should be able to do something smart with, but I do not see it as of yet. This doesn't have all that many values it can be. It can't be 1, 2, or 3. It could be 4. It can't be 5. It can't be 6. It could be 7. It can't be 8. And it could be 9, I suppose. This is a 4, 7, or a 9 only. Let's see. I again kind of want to ask if all of these can be shaded. Does something go wrong if all of these are shaded? Because if all of these being shaded is a problem, then it resolves this clue. But if all of these are shaded, then this becomes unshaded, 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 shaded. Okay, I'm going to draw that in just to visualize it. If this is a 9, all of these are shaded, so then these are unshaded. So then what has to happen with this? I guess this is one of each either way. Doesn't necessarily matter. Again, annoyingly, I don't see anything where, like, this all becomes green. Does not seem to break immediately, as best I can tell. Oops. Okay, let's see. Kurabon says row 3, column 8 must be green because the region needs to go down. So whatever region this is in. It can't go down over here because why? Would that break this? 1, 2, 3, 4, 5, 6, 7, 8, 9? It would not, as long as this came around like this. Oh, but that would break because that's too many greens. That's a 2x2 of greens. Okay, so if this 2 tries to get down by coming over here, it creates a problem because it stops us from being able to finish this. Okay, that's very subtle. Okay, so this is green. Very good spot. And probably actually has to go down even further than that, because this still can't ever take that cell. Because basically the point is... Yeah, the point is this 2 can't ever take this cell. So that's only 5 at the moment. So it's got to take another one down there. Now it could probably... Oh, but now the 2s are very interesting. Okay, so now, what if I don't take this cell? If I don't take this cell, then I'm limited to taking these cells, and that's not enough. And I can't take a second 2. So actually, this also has to be green, I believe, in order for that to work out. And all of this I know is part of the 2 region, wherever it goes. Something like that. So now we know the shape of the purple region in column 9, because now this does that, and so it's an L. So that is good. So we can finish this. Okay, I'm very glad I didn't try and spend forever proving that this could take the 6. I thought I could do a really long bifurcating proof that this region had to take this 6, but it did not take the 6. So that is good. So now we can do our whole thing of where is 1 in this region. 1 is here. And now that being a 1 means that's a 1, because I need a 1 in this region. Now that being a 5 means that's a 5. This being a 6 means that's a 6, because I need to get a 6 into this column, so this isn't a 6. And now this region needs the 6, and so it, of course, has to come up here, grabbing the purple, which immediately makes that green. And additionally, that concludes this region, because this region's now 9 cells, right? 1, 2, 3, 4, 5. Yep, this is now 9 cells. So this is the 6. That's a 9. That's a 1. And draw an edge here. But we need to avoid a 2x2. We need to avoid a checkerboard, so this becomes shaded. So this is unshaded. So we can continue this up. That up. Okay, now I count what's going on here, because did we just put an unshaded cell in this column? I think we did. So now the absolute maximum that this can be is 1, 2, 3, 4, 5, 6, 7, 8. Yes. So this is an 8. That's a 9. These are all purple. These are green by the avoid a 2x2 law. We get to draw in lots of edges. Like that. We get to start regioning. This region now has to reach up to the 2. That's 1, 2, 3, 4, 5, 6, 7, 8, 9 cells. So that region's done now. In fact, actually, if you look now, you can ask where this region gets its 9. It has to be there. So these aren't 9. Let's see. I can continue the edge up here. And now all of my arrows are filled in, at least. Something. Let's see. I can draw in an edge along here. That's fine. Okay, so let's see. Alex says he believes that row 3, column 4 is a 9. I think that's probably true. Okay, so how big is this? This is 1, 2, 3, 4, 5, 6 in size currently. Could, I guess, take those, but it does need a 9, and it can't get one here. Could it get one down here? Might be able to get one down there, unfortunately. One of these 2 cells is green, I know. In fact, exactly one of these 2 cells is green if we want to reuse our weird pseudo Kropke dot. Because if both of these were green, we'd have a 2x2. If both of them were purple, we would isolate this thing. So this is, again, a place where I have a green-purple pair. And the same is true up here, actually. If these were both purple, I would isolate this clump of green. If these were both green, I would make a 2x2. So that actually lets me say, okay, there's maybe one cell here, but then this becomes a giant region. And there's maybe one cell here, but even if I took both of those, that would be 1, 2, 3, 4, 5, 6, 7, 8. This would still come down here and take that. But someone's about to say something about this needing a 2. I predict. Okay. And this region, this purple region, the bracket, it needs 2 more cells. It's only 7 cells currently. And so it needs 2 more, and there's only 2 it can get. So it finishes like that, actually. And so then these are green. And so we actually finish our regions. Let's see. Well, we almost finish our regions. Let's continue this. That. These all go together. 1, 2, 3, 4, 5, 6, 7. Okay, so these now all are forced into this region. And so now this last thing is a region and it is done. So I can get rid of all of my lines now because now all of my regions are complete. I can't imagine what a negative constraint would even mean on a puzzle like this. It's like there's no combination of arrows you could draw into this cell that would be correct. Because of the fact that it's counting double arrows, I think, is probably what would doom everything. All right, and now Alex's point is very easy to see, which is that this region needs a 9, and it can only get it there. Let's see. Am I just going to start writing in digits? I might just start writing in digits. This isn't a 9. Oh, it's not a 1 either, because there's a 1 in the column already. So, in fact, that's an 8, and that's a 9. So that is nice. This is not a 9. Bet cell holding strong, for what it's worth. Let's see. Let's see. This needs to be a 6 because the backwards 3 needs a 6, and there are 2 6s looking at the region in very uncomfortable places. So this is a 6. Let's see. I'm just going to fill in all these places where we've got only a few digits. So we need a 3, 4. We've got a 5 and a 6. We need a 7. We've got an 8, and we need a 9. Let's see. This isn't a 9. This isn't a 9. This isn't a 4. Close. These digits are, we've got a 1, we've got a 2, we need a 3 and a 4, we've got a 5 and a 6 and a 7, we need an 8 and a 9. This isn't 8 or 9. Exciting. This isn't 9. Less exciting. And that's all we've got for those, I am afraid. Let's see. Okay, where is 6 now in this region? It's in one of these two at least. I don't think I know anything else. I wish I could double click and have it highlight where all the 9s are, because I suspect we have almost, but not quite all of the 9s. We might be able to do well if we could do that. Let's see. Row 7, column 6. Is that row 7, column 6? The claim is this is the 9 of the region. Let's see. The 9 of the region is not there. It's not there, and it's not there. Yep, that is the 9 of the region. Thank you, Garion. That's the 9. So this isn't a 9. And so therefore that's the 9 of this region. And that might be all the 9s now. No, not quite. We've got a little tiny X-wing on 9s in these outer regions that we have to resolve still. The 6 is in one of these two cells for this region, I believe. 8 in the 3 region. Let's see, no 8 there. No 8 there. Yes, 8 is here. Thank you, Tallcat. Oh, I can certainly fill in these cells now. That will make my life easier. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that tells me what this is immediately. This is a 1. Now I can update these pencil marks. This isn't a 4. This isn't a 3. This isn't a 5. All very disappointing. This isn't a 4 either. This isn't an 8. Oh, that gives us a 3-4 pair in the column. So that tells me that that's an 8, and therefore that's a 9. That's good. This isn't a 9. So that gives me a 6-7 pair, which tells me that that's a 9. So that's all of the 9s, I believe. Okay, so I've got this 3, 4. I've got this 6, 7. 4 in column 3. Yeah, not in any of those cells. Ah, beautiful. This single 4 actually blocks off 3 cells and the rest of the column. Yeah, so I'll fill that in, and then I should be filling in. I should have just filled this in already. It is very disappointing that I did not just mark these for candidates to see that. 1, 2, 3, 4, 5, 6, 7 is what these digits are. That's not a 6, though. Let's see. Maybe I don't know anything about the rest of them. The last one in column 4. Oh, excellent. Let's see. Is it there? It's not there. It's not there. Yep. Excellent. Thank you, Alex. So now I get the pleasure of writing in these cells. Because we've got a 1, a 2. We need a 3. We've got a 4. We need a 5, 6, 7. We've got an 8 and a 9. Except this one's not a 3. It's a 5, 6, or 7. It's not a 5 either. That one's not a 5 either, for what it's worth. So this is a 6 or a 7. This is a 3, 6, or 7, maybe, possibly. The 9 in the backwards 3. Don't I already have a 9 in the backwards 3? 8 in row 4. By the way, welcome back, Screaming Ice Cube. It's been a bit since I've seen you around. Let's see. So 8 in row 4. Could be there or there, maybe? Where's the 4 in column 4? Let's start there. The 4 in this column is not here. It's not in any of these places, so the 4 is only here, actually. So this is not a 4. Speaking of things that aren't 4, this is also not 4. Nor is it 8. It is 5 or 7 only. So this is also 3, 5, or 7, except it is not 3, so it is only 5 or 7. Meaning that this is the 3 for the column. So this is the 7. So this is not a 7. So we've got our little chocolate teapot triple of 5, 7, and 8, as Mr. Goodliff would say. Let's see. We have a 5, 6, 7 triple in the backwards question mark, I am told. Is that this one? I only count 2. Oh, this is the backwards question mark. I see. That is a 5, 6, 7 triple. Meaning that this is a 3. Got it. Slowly, but I got there. So that's not a 3. So one of these two is a 3. I don't know which one yet. So probably should pencil mark these cells since I haven't yet. 1, 2, 3, 4, 5, 6, 7, 8. Let's see. This is not 6 or 8. This is not 4. This is not 8. This is not 8 or 5. 4, 6, or 7. I guess this is also 4, 6, or 7, but it's not 7. So this is 4 or 6. How are there that many options? It seems like that's too many options. Okay, curiosity question. Isn't Tinder free? I feel like the advertisement cheaper than Tinder is not accurate, but I admit I do not use Tinder, but I had believed it was free. Maybe I'm wrong. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. No, not 9. 6, 7, 8 is the only things left in this column. Where is 3 in this row? 3 in this row only goes here. So this is not a 3. So where is 3 in this row now? Only here. So that's a 4. So I feel like they would teach you in business school, don't compete with a free product on price. So this cell is not 1 or 2. Could be 3, but not 4, 5, 6, 7, 8, or 9, so it is 3. It's probably the last 3 if I were to hazard a guess. This 6 looks down here and says that that's a 4. So this is a 5 or an 8 to finish the column. I don't know which yet. let's see, 6 in column 5. Oh, one of those unfortunate moments where I looked up to see that Tall Cat was telling me the piece of advice that I had just seen. If only I had read Tall Cat's comment just a little bit earlier. Row 7 is done. Ah, yes, row 7 is done. The 4 gives me a 7 and a 6. These aren't 7. None of these are 6. Let's see, that's now a 5 or a 7. 5, 7, or 8. 4, 5, 7 business. 6 in the region with the bet cell. 6 in the region with the bet cell is in one of these two cells. Good point, Carl. So because one of these two is 6, this is 7. That's 6. Making this not 6, famously. Giving us a 5-7 pair in the backwards question mark, as some people have called it. So this is now a 6. Making this not a 6. Placing the 6 in the bet cell region, as it has been known to its friends, as going there. Yeah, I do feel this stream is probably difficult to parse without chat. But at least in the VODs, we do have the chat there. The 7 there looks right, makes that an 8, and that a 7, and that a 5, and that an 8, and that a 5, and that a 7. The 5 makes that a 4, makes that a 5, makes that a 7 and a 5, makes that a 7, 5, 7 makes that a 4. Probably doing pretty well at this point, I'm going to say. We've got a 7 in the row already. We must have... Oh, we've got a 7 and an 8, so that's a 5. We've got a 4, 5, and a 7, so that's an 8. And we did it! Excellent. You will make a puzzle site, but it will be entirely paid for by porn bots. Is that the plan? Afraid not. Could be popular with the right demographic, I suppose. That's right. Yes, in the VOD directionary points out that all the things that have been removed will actually stay removed. So I will just out of nowhere in the middle of this solve of this puzzle, I will be asking chat about Tinder and its price, which will give perhaps watchers a different impression. So the bet cell was a 7. This is a lovely puzzle, by the way. Thank you to chat for voting on this one. I enjoyed this one, or to my windmills and turbines for voting on this one. By the way, if you would like the fancy power to vote in which puzzle, because every stream I do the most voted on puzzle is my first puzzle, except today where I did it as a second puzzle for reasons. But if you would like to do that, you can become a windmill or turbine in 2 different ways. You can either become a YouTube member, which you can do by clicking on the join button, or you can go to patreon.com/zetamath, and we will... and then you will be bestowed with the privilege of voting on these, and I will always thank the people who voted for it, and then do it. Oh, and speaking of, Tallcat has become a windmill, which YouTube has written as "Welcome to Windmill." Welcome, Tallcat. Thank you very much for the membership pledge. Alrighty. I'm going to take a short break after that. That was very nice, and somehow I either misremembered or whatever. I thought someone had said this was the hardest Jesper puzzle, which certainly for me this is not harder than the other one. Tallcat just wanted the stop Zeta emoji. Yes, well, you do get, if you become a YouTube member, you do get some emojis, and you get a fancy windmill and a green name. It's all good stuff. You get some penguin emotes with a Zeta on the belly, so you can celebrate Zach. Anyway, I'll be right back with another puzzle, so I will see you all very shortly. Welcome back, everyone. We're back with a puzzle by Memeristor, who is often in chat, and I clicked on the ad for the Sudoku pad thing. So we have a puzzle that features both region sumlines and German whispers, both of which you will notice I am quite fond of. So this was an easy sell for me to do. So just to refresh, German whispers, in case you are new to the channel, German whispers, digits next to each other on it have to differ by at least 5. So if I put a 4 here, both of these have to be 9. Oh, you're going to bet before I place down the bet cell. Let's place the bet cell there. And then on region sum lines, these are like fancy arrows. The sum of these 2 digits is identical to the sum of these 2 digits. And same with every one of these. So these 2 digits sum to the same as these 3 digits. These 2 sum to the same as these 5, and so on. Okay, so that's that. Now, I think I already noticed something by looking at this combination of cells. That was a terrible, terrible way to highlight that. I think this combination of cells is interesting. Because what's the minimum that these 5 cells that I have highlighted could sum to? And so, a priori, you could think, the minimum that these could sum to is 1, 2, 3, 4, 5, which is 15. But this German whispers needs a low digit on it. So it needs a 1, 2, 3, or 4. And so actually the minimum I could make is 1, 2, 3, 5, 6, which is 17. And in fact, the maximum I can make these 2 is 17. And so in fact, you get right away that these are 1, 2, 3, 5, 6, and these are 8, 9, and this is 4, 9, because I need to have a 4 on here. And then we get to bring in Zach for the 8 dance. 1 8 dance, please, Zach. Thank you. Whoop, 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 lip, 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 lip. Ah! Sorry, Zach. Zach fell down. Whoop, 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 Thank you, Zach. Oh, links. Tristan should have links available. So yes, so we can do exactly the same thing over here, where we'll go ahead and enter our 4, 9, our 1, 2, 3, 5, 6, our 8, 9, which is in this case a 9 and an 8, which gives us a 4 and a 9. And there we go. So that's swell. So now 9 goes in one of these 2 places in this box, I suppose. I don't know if I want to high-low color this or not. I'm not sure yet. I might do it anyway, even if I don't need to. But let's continue for a moment thinking about this. So I've got an 8 somewhere along here. Oh, I should fill in what these digits are. That's probably a good idea. These are a 7-8 pair. And so these are also a 7-8 pair. And so that pushes 7 and 8 into these places. Oh, in fact, actually, as Nicholas points out, I can do better than these are a 7-8 pair because there's an 8 here. So it's actually a 7 and an 8 straight like that. Thank you, honey, for the grape. All right, so we've got all of that going on. This is all going to come to a screeching halt. Don't worry. If you think this is going too well, fear not. Okay, so there's an 8 and a 9 up here. The 9 isn't there. Now, here's an interesting point, actually. The 8 and the 9 can't both be on the region sum line. Because if the 8 and the 9 were both on the region sum line, the sum would be 17, and these two would need to sum to 17, so they'd have to be 8 and 9, and there's about 6 different problems with that. So in fact, this cell is always an 8 or a 9, which means this cell is low, this cell is high, and this cell is low. Now I can clean up some of that. For example, this can't be an 8 or a 9, so this is a 6 or a 7. So actually, these can't be 3 or 4. They can only be 1 or 2. And so we have all of this. So we can do exactly the same thing over here, but I've had a request for coloring, so I think we should probably color the high digits orange in order to make the world a happier place. And we'll color the low digits blue in order to also make the world a happier place. And then we'll do exactly the same trick over here. Over here, we need an 8 and a 9. That one's not the 8. But again, these can't be an 8-9 pair, so one of them has to be here. And so these are orange. These are blue. This is again a 6 or a 7. And so these are again a 1, 2, or these are again 1 and 2. Now, fun fact, one of these actually is a 6. So actually, these two digits are the same, because either, for one of these, they're both 1s, because it's a 6, and 6 only goes with 1. And for the other, they're both 2. I don't know if I want to subcolor that, but who am I kidding? I'm going to anyway. These are the same digit. So we've got all of that going on. So notably, the black digit is one of these two, so the black digit's pushed over here, and the yellow digit is one of these two, so the yellow digit, oh, I guess that's not as relevant. The yellow digit's pushed over there, but it's not doing anything. Okay. What is the absolute maximum that these two things could sum to now? It's 5 and 6. The maximum these could sum to is 11. I guess that's not exciting. It looked exciting for the briefest moment in time. Okay, so this digit, what can it be? 3, 4, not 3, 4, 5, not 6, 7, or 9. It could be an 8. Okay, I don't really feel like pencil marking that either. Okay, what are these cells? Maybe I want to do that? That also seems excessive, I'm going to have to admit. What do I want to do that's not excessive? Thanks, Memeristor. It's going really well so far. We're 8 minutes in, and we've got tons of digits in the grid, so I'm pretty happy with that. Let's see. Black in box 2 is in one of these two cells. Okay. I think it's... Oh, no, it doesn't work the same. I was hoping to put both black and yellow on here, but it does not work, unfortunately. Oh, wait, no, it does. Okay. Where is yellow in box 8? Yellow is in one of these two cells. I'm just going to put these as gray-yellow to say one of these two is yellow. Yellow's definitely over here. And so both yellow and blue are over here. So whatever this is, that being because one of these is blue, and so blue gets pushed over here. Whatever this is, it has a 1 and a 2 on it. So this sums to a minimum of 7, but a maximum of 12. So this is a 1 and a 2. If I need to get to 7, I need at least a 5. And then, so this could be 5, 6. It can't be 7, 8, or 9, though. So actually, oh, yellow and black rather than yellow and blue. You're right. Black was the color. Blue was just low. Black was the color of my special thing. So 0, 1, 2, 5, 6. And that's because I can't put 7, 8, or 9 down on this line. So these either sum to 8, in which case these would be 3, 5, or they sum to 9, in which case these would be either 3, 6, or 4, 5. So these are from 3, 4, 5, 6. That one's never a 4. I'm going to get rid of this coloring just because it's a little bit distracting, but that's how we got that these were over here, was through that mechanism. Okay. Now, Sayori has a good point that I had not fully appreciated over here, which is that I'm going to do the same thing. Yellow is here, so yellow is here, so yellow is over here. Black is here, and black is here, so black is up here. Yellow and black are both up here, but they can't both be on the region sum line, because then the region sum line would sum to 3. This is just a delightful setting, by the way. I love this. And so if this did sum to 3, these would have to be a 1-2 pair as well. So this is a 1-2. This is either yellow or black. I don't know which. It's low, though, so I'm going to go ahead and color it. Where does row 8, column 4, go in row 9? Asks Afraid Not. Oh, that's a good question. Okay. Where does this cell go in row 9? So if this is, well, if it's a 3, it doesn't go anywhere, is the problem. So this can't be a 3. If this is a 4, then of course it goes over there. And if this is a 5 or a 6, then this is a 3. And it goes over there. So we get an elimination from that this is not 3. This is 4, 5, or 6. Okay. All right, there's a claim that if I ask about the 7 in row 7, that I learn interesting things. So if I put the 7 here, it joins its friends, the 8 and the 9, and this sums to at least 15. And so if this sums to at least 15, well, this would have to be 7, 8 in order to get to at least 15. 7, 8 is the absolute maximum. But then this is also 7, 8. That does not work. And since this is a maximum of 7, 8, I can't shuffle stuff around to make that better. So one of these two cells is a 7. So one of these 3 cells is a 7. But this isn't the 7 because there's a 6, 7 pair. So this is the 7 and is orange. So there's a 7 in one of these 2 cells. If the 7 were here, is that a huge problem? Let's see. I know there's a 1 or a 2 on this. Oh, yeah, there's a huge problem with that. Okay. 1 of 1 and 2 is here. And the absolute maximum digit it could go with is 5 or 6. So the most it could sum to is 8. So if I put a 7 here, that does not work. So this is a 7. It's too big if I do that. So for that matter, let's write down what are these actually. So this is a 1 and a 2 and something like a 5 or a 6, because the minimum sum here is 7. It's if this is 3 and 4, then I get to 7. So the sum is 7 or 8. So I could not dip any lower than 5 here in order to make that work. That's the point. And so one of these is definitely a 3, and it's either a 3-4 or a 3-5. And that one's not a 4. But there's definitely a 3 on this line. And now, this is gorgeous. Where does 3 go in row 9? Well, 3 only could go in one of these two, but now it can't because of that. And so 3 goes here. Oh, welcome back, Franco. Oh, and welcome to being a windmill, Jay. Thank you so much. Greatly appreciated. Enjoy all the powers and privileges that come with being a windmill. Thank you so much. Greatly appreciated. I really appreciate all of the support that everyone has given us. Okay, so let's place the 3. Yes, you did. You went to fancier windmill. So we can place the 3 there. Okay, this 5-6 now is here, and so that 5-6 is up there. So this is the other 5-6. And so these digits are a pair. They are 4 and something else. Oh, and 1 or 2. They're 4 and yellow is the point. Okay, so we've got that. Okay. Oh, where is 6 in box 2 is an excellent question. 6 in box 2 is just placed here in orange, which then makes this a 5, makes it green. Let's not forget to blue and orange ourselves. We don't want to be cretins about this. These aren't 6. 1, 2, 5. So let's fill in these candidates. We've got a 1, 2, 3. We need a 4. We've got a 5, 6, 7, 8, and we need a 9. So these are a 4-9 pair. Oh, thank you, Afraid Not, for joining the Patreon. Thank you so much. Ooh, we get the dancing T-Rex. Fancy. No, don't worry. Zach and the T-Rex hang out off stream. They're fine. 1, 2, 3, 4, 5, 6, 7, 8. These are 5 and 8. So in particular, these are not 5. So actually, these are both blue, it turns out. Twist. That's a 3 and a 4. So these now sum to 7. Yeah, you can get up the votes. So far, the most votes a single puzzle has gotten, I believe, is still 4. But now with all of these new people with voting powers, maybe we can get a most voted on puzzle with even more votes than that, which would be exciting. Let's see. These are from 1 to and something else. 3, 4, 5. Therefore, 1, 2, and 5, it turns out. So, funnily enough, and I think this is true of... Oh, it's not true down here, but it is true up here. This is a 1, 2, 3, 5, 6 quintuple. Almost as good as a sextuple, but you have to go to Tinder for that. So these are what's left over, a 4, and an 8 and a 9. So that's not an 8. That is a 4 or a 9. So this is a 4 and an 8 or a 9, interestingly enough. Let's see. If this were a 4, this would have to be a 3 and a 1, which is, I guess, possible, sadly. Let's see. I meant to review row 1. It helps a lot if I do Sudoku. So the 6 is there. So now I need these to add to 7. That probably means I want them to be a 2 and a 5, which means that this digit is a 1. So this isn't a 1 anymore. Thank you. So these digits I should go ahead and fill in. They are 3, 4, 5, 6, 7. These are 3, 6, and 7. That one's not a 7. These are not 3 or 6 anymore. They are 1, 2, 5. Cool. Okay, so what if there's no 9 on these two cells? If there's no 9 here, the maximum that these could sum to is 6 and 5. That's perfect. Okay. If there's no 9 in these two cells, the maximum they sum to is 5 plus 6, because there's a 7 and 8 gone, which is 11. But the minimum these sum to is 4 and 8, which is 12. So it could not work out more perfectly that there has to be a 9 there, which means that this cell's blue, and this cell's orange. So that's the 4. Take 2. That's the 4. And this isn't 4. And I can demote the 8-9 pair there to eschew them. So let me just write in what these digits are. We've got a 1, we need a 2 and a 3, we've got a 4, we need a 5 and a 6, we've got a 7 and 8, and we need a 9. That one's not a 9. Okay, so I need to get to at least 12 with 9, so I cannot do 2. But I also need to get to at most 13 with 9, so I can't do 5 or 6 either. So, in fact, the only combination that works is that this is 3, 9, summing to 12, which would make this an 8 and this a 9. This is now a 6, fun fact, because of the 3, 6 pair. So these aren't 6 anymore. They're a 3, 7 pair. I can look down and I can remove 3 and 6 from these two. So this is 2 or 5. Okay, so that gives me a 9, not an X-wing, but my 9s are aligned in these two boxes, which pushes the 9 in this box over into one of these two cells, which I cannot imagine mattering in any way, but it's true. Oh, there's a 9 in column 7 now that is doing work. Thank you, Kurban. Oh, I could have done this whole thing way easier, couldn't I? Oh, no, I don't think so. I don't think the 9s were aligned before now. I had a brief moment thinking that if I'd done this, I could have eschewed the whole "does this need a 9" argument, but I don't think so. I think that was good. Okay, so we've got all of that good stuff. But they only became aligning once I marked the 9 here, right? Because I'm marking the 9 here is what removed 9 from this cell, I think. Oh, well, whatever. If I could have done it a different way, I like the way I did it anyway. Does this mean I'm making it? I think this means I'm making it. The fact that we're getting bots just out the wazoo today. Let's see. The dark blue 12 sees both 2s in column 9. Ah, okay, I understand now. The 12 is the 1-2. That is gorgeous. Wow. Good spot. So if black is 2, I can no longer put 2 in column 9. So in fact, black is 1 and yellow is 2. Great spot to Sayori there. Not yellow, not black. So these aren't 1. These aren't 1 either. These aren't 2. Did you accidentally ban a porn bot earlier that was actually here for the Sudoku? Row 5, column 5 looks right. Sure does. I read that wrong at first, and my original reaction to reading the sentence row 5, column 5 looks right is, well, good. But then I understood it eventually. So this is blue and this is orange is the point. So that's a 3 and a 9. The point being that this 3 resolved the 3 and the 9. So that 9 now resolves the 4 and the 9. The whisper lines, right. So now this is the 6 and that's the 7. Because remember, the 6 needs to go next to 1s. Very nice. Let's see. I'm checking to see if this could possibly be a 5. If this is a 5, it would need to be 1, 4, and it would need to look exactly like that. But that unfortunately seems plausible, as best I am able to tell. So should I attempt to figure out how to make 9? Seems like there's lots of ways. I could do 1, 8, or 2, 7, which would look like that. Or I can't do 3, 6, or I could do 4, 5, which would look like that. Seems a little egregious. Let's see. I can't do 2, 7. Oh, there's a 7 there. Okay, no 7 and 2. The 2, 7 pair. The 7 was hiding. It was camouflaged by the whisper. We will say. Okay. So what is my minimum sum here? I need an 8 or a 9 and a number that's at least 3. So this needs to sum to at least 11. But that doesn't seem that hard. There's not a whole lot of restriction in this column. Like, I can certainly sum to a number that's high enough without using an 8, for example, which would be the mirror of the thing we did over there. Let's see. If this was an 8, am I supposed to ask myself what this is going to be? It would have to be 2, 6 or 1, 7. So it would have to be... That doesn't seem that difficult to me, if I'm honest. Come on, Memeristor, tell me your secrets. Okay, I know there's a 3 down here somewhere. This seems like reaching. I don't think that's going to help. Yes, if it's a 5, it's a 1, 4, and one way only. I agree. If this is a 5, it's 1 there and 4 there. Let's see. Is there some restriction I am not appreciating on 4s generally? the 4 in this box is in one of these spots. It does feel like I need to do something with one of these arrows. I don't think I have a whole lot of other options. I don't think there's anything I can do with this region sumline, is there? If you put 3 on row 6, column 1, then the highest you can make it is 11, and then you'd need to do 11 in box 7 without 2 or 3, but you'd need an 8 or 9 on it. Okay, so if this is a 3, the most I can make this is 11. But this has an 8 or 9 on it, and does not have a 1 or a 2, so it's at least 11. But I can't make this I can't make this 3-8 and this 3-8. That's too many 3-8s. So this is not a 3. And so, in fact, thanks to Garian's point, we actually find out that there's a 3-9 pair here, which feels very, very out of nowhere to me. So that does what? Well, it means that if this is an 8, it's not 3-5 anymore, because now there's a 3 looking at it. Oh, I guess it could never have been 3-5. Never mind. 4 in row 4. Not there. Maybe there. Maybe here. Not there. Is there a reason 4 can't be here? 4 in row 6. Okay, 4 in row 6. Not there, or there. Okay, now, okay, so 4 in row 6 now is placed here. Beautiful. Okay, that was a very nice spot. So that can't be a 4. This being a 3-9 lopped out the possibility that either of these was a 4 very nicely. None of these are 4. This isn't a 4 because there's a 4 down there, and so this is a 4. And now you know what you can't make with a 4? 8, because you would need a second 4. So this is in fact green. This is orange, as you may have been hoping. So this is blue. So that should do something, maybe, possibly. Well, it certainly removes the possibility that that's 1 and that's 8, which guarantees that this is blue. Okay, let's fill in the rest of this row, because we've only got a triple left. We need a 2... Oh, that 5, actually, sorry. Before we do that, let's notice something else. That 5 gives us the 2, which gives us the 5. So let's just suck out all the 5s from there. So now these 2 digits are all that's left, and they are a 7 and an 8. And, well, I'm just going to write in 7, 8. I don't think I know which order they go yet. So that is 7, 8. Now, this 1, Kurban has pointed out, is placed here. So that cell's blue. So we've got that. I still haven't disambiguated this part up here yet, surprisingly. The 8 in box 5 looks left. Excellent. Thank you, Franco. So that's 5 and 4. And so that's going to remove 5s from there. It's going to place a 4 here. So the bet cell is a 4. So congratulations to everyone who bet 4. We have an official bet cell declaration. So that makes that a 2. So this is blue, not yellow or gray. This is also blue, not yellow or gray, but blue. So that's 2 and that's 4. So this is not a 2. So have a good rest, Nicholas. Thanks for all your help today. I feel like you had many good spots in the Jesper puzzle, especially. Your first bet cell success. Congratulations, Liz. It's all uphill from here. Once you get your first one, then you really get the feel for how to sense the digits. 3, 4, 5, 6, 7. These are from 3, 6, 7. Is there any way I get away with not putting a 3 down here? Because if I put a 3 down here, what's left in the box? What's left in the box is 3, 4, 5. No, sorry, 5 is down there. 6, 7, 8, 9. If I don't put a 3 down here, then this sums to at least 14. Is there any way these two cells sum to at least 14? They would have to be... Maybe that is possible, annoyingly. This one would be at most 7, but then this could be 7 and 8. That would be fine. With 6 and 9 down there, that seems actually quite plausible. This isn't a 5 anymore, so it's blue. Oh, that's become blue at some point while I wasn't looking. So that's a 1-2 pair, so this is not a 1 or a 2. Let's see. Okay. What can this cell actually be? Maybe that's the easiest way to do this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this can only be 2, 6, or 7. There are no other options that are allowed for it, even by magic. So if this is a 7 and an 8, then this is a 15, no problem. If this is a 6 and a 7, I would need to make 13, which I can't. If this were a 6 and an 8, I would need to make 14, which I could only make a 6 and 8, so that's not going to work. So this can never be a 6. And if this is a 2, I just don't get big enough, because 2 plus 7 and 8 is only up to 10, and this is way bigger than that. This is at least 11. Okay, by way bigger. It is 1 bigger, but it is enough bigger that it breaks, if that is that. So this is orange, and it's an 8. So this is not an 8 or a 3. It is a 6-9 pair, so that is an 8. These are both orange. So these are both blue. That's orange. So that's a 6. These aren't 6. Oh, I actually know that which way the 6-9 pair goes. That's a 6 and that's a 9. So this is blue and that's orange, as we are used to saying. It's 3 and 9. So now the 3 is placed in the box here. Oops. Because that can't be a 3 anymore. This is now not a 3, 6, or... So this is a 7 now. So this isn't a 7 for a few different reasons. Take your pick. This isn't a 7 either. Nor is it a 2, actually. So it's a 6. So this is a 2. Gorgeous. Okay, so these aren't 2. That one's also not 3. That one's also not 2. That gives us a 1-5 pair, actually, which makes this a 6. Makes this a 6, sorry. 6 is the orange color, as we always say along the stream. That's a 6, so that's a 3. So this is not a 3 or a 6. Say 1, 2, or 5. And as far as I know, it could be any of them. Let's pencil mark this row. 1, 2, 3, 4, 5, 6, 7, 8. Well, this one's not an 8. I feel like I should know something else, but maybe that's literally all I know. This one's not a 5 or an 8. It's a 1 or a 6. Oh, and it's not a 1 because there's a 1-2 pair. So this is a 6. Oh, Naverio is here. Hey, Naverio. There's a 6. Let's see. This one's not a 1. This one's not a 1 either. So this is a 5-8 pair. So this is not a 5 or a 6, so it is a 1. Meaning that these aren't 1s. This, I probably know what it is. It looks orange to me. That is my feeling. You can let me know if it also gives you orange vibes. So this is now a 3, so it's blue. So it's blue. So that's orange. And now that's going to resolve a whole bunch of stuff, because now this is 3 and 7. That 3 is going to resolve a 2 and a 3. That 2 is going to make this cell turn green with envy, and this cell turn blue. So that's a 5 and a 2. So this is an orange and a green. 8 and 5. Let's see. This 2, if I actually paid attention, would give me a green over here. So that makes this cell turn blue, makes this cell turn blue, makes this cell turn green, makes this cell turn, it's got to be blue, so this cell is green. So we finished our coloring. So that's a 5, that's a 5, that's a 5, that's a 2 and a 1, and a 2 and a 1. And I'm not anywhere near done. I mean, I'm nearish done, but I thought I was done, but I'm not, because that's a 1, and that's a 7, and that's an 8. There we go. Really nice puzzle. I gave green, or I gave 5s green today because I said that I was in a very good mood, because right before I went to stream, I found out that Simon was going to do a premiere of my puzzle MIA, and so I was excited. So I started the day by doing greens. I like Jay's suggestion that 5s are green now because 5s paid for a YouTube membership. I somehow suspect that 5s will not be the digit that chooses to join my channel's YouTube members, but if 5 is interested, I'm open to talks. But yes, green is a happy color. I am happy with it. Alrighty. This is stream 55.5. That's a good point. We could not have had more 5s in a stream title than 55.5. Alrighty. I'm going to take a short break, and then we'll be back with another puzzle. Alrighty, welcome back, everyone. Next up, we have this puzzle, OBI-Sudoku by Olima. A benefit that I talk about less is that if you of the joining the Patreon / YouTube members is that if you join at the highest levels, then you get to specifically request puzzles. And so this puzzle was specifically requested by Franco, and I'm happy to do it. So this solve is dedicated to Franco. So we have here this olima puzzle. Have normal Sudoku rules apply, and then the digits in these cells are two different things. The first thing is that they are odd, so the digits in them are 1, 2, 3, 5, 7, 9. 9 is also an odd digit, and also they're the box indexing. They're a box indexing cell. So, for example, if this cell was a 7, it would tell you the location of the 2. The 2 in this box would need to go in the 7th spot in the box, so that would be there. Did I list 2 as an odd number? 2 might be odd-ish, question mark? So this is using, by the way, the indexing system 1, 2, 3, 4, 5, 6, 7, 8, 9. So all the boxes, you're supposed to think of this as 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this cell, if it's blue, will tell you the location of the 1. This one will tell you the location of the 2, and so on. So we can delete those. So we're going to have to do something a little weird here, because normally in a parity puzzle, I would want to color, and I'd want to color evens blue and odds orange. But we can't, because these boxes are kind of bluish to start. And so instead, I'm going to color the odds in... Let's make the odds purple in order to sort of make them complement this this blue background. So we'll make them purple. And then to complement the purple... we'll make the even color yellow. So all of the purple digits I can write in now. They are all 1, 3, 5, 7, or 9. Now, there's lots of cells that we can tell right away have to be even. So, for example, this box has all of the non-even digits. So all of these are yellow, because there's 5 odd digits. So these are all even. In this column... there are 5 odds already, so we're there. In this column, there are 5 odds already, so the rest are yellow. In this row, there are 5 odds already, so the rest are yellow. In this row, there are 5 odds already, so the rest is yellow. In this row, there are 5 odds already, so the rest is yellow. In this column, there are 5 odds already, so the rest is yellow. In this column, there are 5 odds already, so the rest is yellow. Let's see. In this row, there are 5 odds already, so the rest is yellow. I swear I did that one already. Well, this box now has 4 evens, so the last digit is odd. And now this column has all of its odds. No, it doesn't. This column has all of its evens, so that's odd, actually. Let's see. This row has all of its evens, so these are odd. Let's see. Do I have anything else that I can do? I mean, I can certainly think about other things other than coloring odds and evens, but I like coloring, so why don't I just think about coloring some more? But I'm not actually 100% sure that that's going to work. So let's go now, and let's update our pencil marks. So, for example, Oh, sorry. So for example, this cell, let's see, this might be a little bit painful to do. This cell can't be a 7 because it would index a 3 into this cell that I know is even. This cell can't be a 9 because it would index a 3 into a cell I know is even. So this is a 1, 3, or 5. Let's see. Okay. This is 3, 5. So the key is in each box, I want to highlight everything that has an odd position index. So in this case, all of these have an odd position index. There are 3, 5, 7, and 9. And so they can't be 1. So they are a 3, 5, 7, 9 combo. And so therefore we get our first digit that this is a 1. And now we get to do the 1 dance with Zach. 1 dance, please. Thank you, Zach. Do. 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 Oh, I'll get you a bet cell after Zach's 1 dance. Doop. Doop. Ah. Boop. 1 dance. Woohoo. Thank you, Zach. Much appreciated. There we go. Tolkat has confirmed on his choreography sheet that that Zach has done the correct 1 dance. Okay, so another thing I am noticing over in this box that I did not do is that this is saying the 3 can only go either here or in the 5th spot, so these cells are never 3. I have a kind of hard time imagining that if I just keep updating my pencil marks, this puzzle isn't going to solve itself, but I'm not sure. Let's see. Okay, so this is the 4th spot and the 8th spot and the 9th spot. Okay, so this is the 9th spot. So it can't be a 1 because that would put it in an even spot. And it can't be a 7 because that would put it in the spot with an even digit. Oh, it's actually just a 3 in the 3rd position. It has to self-index. Oh, don't forget the negative constraint. Right. Okay. So the negative constraint is actually very relevant. If this was a 5, then this would be a 3. And now this is an odd cell that indexes the position of the 5. So it would have to be given, and it's not, because there is a negative constraint. So this is actually a 3. Yes, I was thinking we were going to avoid thinking about the negative constraint until much later in the puzzle, but it turns out it's very relevant immediately because this 3 has to self-reference. Got that. Okay, I think we did that one. Let's see. This is 1, 3, 5, and 9. So none of these can be 7. And so, therefore, this is 7. And so this isn't 7. These can all be anything they feel like. These are 1, 5, 7, and 9. So they cannot be 3. So this is 3. So this is not 3. Going there. And also, these are not 3. Also, these are not 7 because of that. And then we can do exactly the same thing here. As Olima says, there's a lot of symmetry going on. So this is 1, 3, 5, and 7. I cannot put anything in the 9th spot. So therefore, this is the 9. Makes that a 5. Makes this not a 1 or a 5. Makes these not 5s. Makes this not a 9 or a 5. Makes it a 3 or a 7. Column 5, not 1. Okay, yep. Agree. All right. And so there we go with that. So let's see. 3 in box 4. sorry, 3 in box 4. I'm looking at the wrong box. So 3 in box 4 is actually placed. Thank you, Alex. So that's a 3, which then by indexing means that's a 1. That's now a 9, and that's a 5. So these are not 1 or 3. Oops. And these two are also not 5. So therefore, this is 5. The 5 there puts a 1 there. So these are not 1 or 5. So they're a 7-9 pair. So these aren't 7 or 9. Or 5. They're a 1-3 pair. Which makes some amount of sense. These aren't 5 either. That's not 5. This isn't a 1. That's not a 1. Let's see. Okay. Can I place 3s in other places? That was exciting and profitable. I know there's a 3 down there. One of these two is a 3. Don't know which one yet. Oh, I know this isn't a 9. I can do that much. Oh, maybe I can do something like place 9s. Like, that's not a 9 either. Not quite with the 9 there, at least. About the 1s. Well, I can definitely place 1 in one of these two cells. So that's a progress. It's a progress. This is not 1 or 5. It's a 7 or 9. This isn't 1 or 5, so it's 7 or 9. Let's see. Hey, nothing wrong with cleanup. I appreciate cleanup advice. It's often the stuff I'm least looking for whatever reason, because that's how my brain works. I'm curious if I should pencil mark all the yellow cells, because there are lots of things I know. Like, for example, this can't be where the 8 is in this box, because if it was, then this would be a correct OBI cell. Where's 1 in row 3? 1 in row 3 is in actually exactly that spot. Thank you. That was a good spot. So that makes this digit an 8, which makes it yellow. Thank you, Garion. That was a very good spot. Okay, so now this isn't a 1. So now there's a 1 over down here somewhere. Let's see. Row 7, column 1. Right, okay. If row 7, column 1 were any of the digits other than 1, then it would be placing a 1 in 3, 5, 7, or 9. It would be placing a 1 in one of these, 3, 5, or 9. And it can't place a 1 in any of those. So it can't place a 1 in actually 3 or 9. I should have cleaned that one up, and I didn't. But if it placed a 1 in 5, then the 1 would be an OBI, because it would correctly index the location of the 5. So actually, this is a 1. So these are not 1. So that's a 3, 5, 7 triple, which makes that a 9, which means the bet cell's a 2. I did not do my best bet cell picking work this time, I will confess. So that is not a 9. This isn't a 9. Randomly just snipes the bet cell just completely ruthlessly. So let's continue. There's a 3, 5, 7 triple in this box. So therefore, this is a 1. And that being a 1 means that's a 7. So that's a 3, and that's a 5. The geometry here is really something. So that's a 9, which makes that a 3 and that a 1. Uh-oh. Oops. Sorry. How did I break it? Oh, because I put the wrong digit in. This is a 9, which makes this a 1, and this a 3. This is 7. So that's a 5, which makes that a 7. Makes that a 9, and that a 3. That's a 7. So that being a 7 makes that an 8. This is not a 7. This isn't a 5, so it's a 9. So that's a 7, and that's a 9. So this isn't a 9. Double or nothing bet cell. Let's see. If you want to re-bet, I will let you bet on this cell. Oh, in the same box. Well, after this bet cell gets plucked out of thin air, then we'll do one in the box for extra encouragement. 3 in this column. Oh, sorry, this is not a 5 or a 7. So this is a 3. So that's a 2. I didn't. Did I misplace a digit I wasn't supposed to? Oh, that's 7. Makes that a 9, which makes that a 6. Makes that a 7. The 7 makes that a 6 and yellow. And so now I get to purple a bunch more stuff, because now the column is done. The row is done. The box is now done. Okay, the 9 needs to go in this box, so the 9 goes there and the 7 goes there. No, bad. The 9 goes there and the 5 goes there. Better. This isn't a 1, so it's a 3 or a 7. This is a 3 or a 7, and it's not a 7, so that's a 3, and that's a 7, and that's a 1. The 1 here places a 4. The 7 is self-indexing. The 3 places an 8, which is there, so that's a 6. Let's see. I need a 5 in here somewhere. The 5 can't go here, because if the 5 was here, it would be correctly indexed. Oh, did I misplace something? What did I do? 3 in box 9 is not an OBI. Oh. When I said the 3 places an 8, that was a lie. I see. Yes. So this is a 3, but it's not a thingy. So that is a 7. That is a thingy, but it doesn't do anything. And this is a 1, which does do something. It does place a 4 there. But I used this 3, and in fact, I actually know that's not an 8 if I use the 3. Because this would be a thingy if it were if this were an 8. So in fact, this is a 6 because it's not an 8. So that's the 8. Okay. This still can't be purple, though, because if this were purple, it would be a 5, so it's yellow. And this is purple. And the reason this can't be a 5 is because if it's a 5, it is correctly indexed. So that's an 8. Let's see, that 1 looks up here. That's a 3. That 3 indexes the location of the 4 up here. So that's a 4. So now we can do some more coloring, because now this row, we have all the evens, so we can go ahead and place the odds. This box now has all of its odds, so we can place the even. This column has all of its evens, so we can place the odd. This box has all of its odds, so we can place the even. And now we're colored. So we can continue this. Okay, what are these digits? These digits are 1. Oh, the 1 goes there. and 5, which goes there, which makes that a 7, which makes that a 5. And now we have all the odd digits placed. So now I can use the negative constraint on this 5, because the 5, if this were a 2, the 5 would be circled. So that's the 2, and that's the 6. So that's a 6. This is a 6. This is an 8. So this is a 2-4 pair, which I don't think is yet resolved by the negative constraint, but I'm sure in time will be. This is a 2-4 pair. But this can't be a 2. Because if this was a 2, the 7 would be correct, and it's not. So that's a 4, and that's a 2. So the second bet cell, also a 2. So therefore, that's the 2. So that's a 4, and that's a 2. That's a 2. So these are a 4 and an 8. I can't do anything with that yet. These are a 4 and a 6. I might be able to do one of them. Let's see. Okay. All right. So these are 4 and 8. So the 8 in this box is not in the 5th spot. So it's there. So that's a 4 and that's an 8. Uh-oh. Sorry. I literally said the thing and then did it exactly the opposite. The 5 here is not circled. So that's not an 8. So it's a 4 and that's an 8. And that's a 4 and that's a 6 and a 4. So that's an 8. So that's a 6. So these are a 2-6 pair. So this is a 4. So that's an 8 and a 4. So this is a 2 or a 6. So it had better be a 2. And that's a 6 and that's a 2. And that is an 8. And there we go. Nice choice of puzzle, Franco. And nice puzzle, Olima. The very smooth there with figuring it out. And yeah, the symmetry at the end is very cool. I liked that. And it was very fast, because I think actually the timer was even at 8 minutes when we started. So I think I realized I just moused over the timer and you cannot see it, but the timer says 30 minutes. So I think we probably did that in like 25 minutes or so. So very nice puzzle. I'm interested in when Rank's new solver comes out that supports all of these. I'm interested in what people will do with these kinds of constraints. But yeah, good use of the negative constraint to sort of do things. It seemed to always be 5. Maybe it was always the 5s that chased things around with a negative constraint. But yeah, very, very nice puzzle. All right, I'm going to take a quick break, and I will be back shortly with another puzzle. Yeah, I just saw Franco saying it wasn't impossibly hard, but wasn't able to get to it. If chat had not pointed out the point where I had made the mistake, I think I would have had a really hard time picking it up, because it's very easy to accidentally use a cell incorrectly. I was thinking today, it's been a really long time since I've done a Tyrgannus puzzle. So I wanted to do a Tyrgannus puzzle, so I looked and went to find a Tyrgannus puzzle, and this was the Tyrgannus puzzle that I came across. The last Tyrgannus puzzle I did on the stream, I think, was actually Violet Owl, which was many streams ago. I think Tyrgannus doesn't post all of their puzzles on LMD, so I might have to dig up other puzzles. But anyway, I'm excited to do this one. So this is a killer, meaning that the cages here sum to the digit at the top left and don't have repeated digits. And an arrow, where the digit in the circle is always equal to the sum of the digits along the line. And digits may repeat along an arrow if allowed by other Sudoku rules, so don't forget that. Very relevant in this puzzle, I can almost promise. So there are a few gimme cages here. So a 6 in 3 is always 1, 2, 3, especially if I do that. Oh, maybe I should enable, let's see. Maybe this time it'll actually let me if I enable the cheating thing. No? No? Where did it go? There used to be a tool here that said you could do the whole killer thing, but it's gone now. So we're gonna have to fly close to the sun without checking. Oh, is it under advanced? Was there an advanced button? Oh, there is an advanced button. There we go. Killer calculator on. There we go. Okay. I don't know how to use it, but we'll see if we want to use it. 6, 8, 9. Oops. Is the only way to make 23. 7, 8, 9 in 3 is the only way to do this one. 17, there's 2 ways to do. So we've got our work cut out for us. 18, there's like a bajillion ways to do. Oh, there we go. Okay, so it shows it to me over here. You can't see it, but oh, Sven says it may not be completely ready to use. Well, I can at least it seems to work for me. Oh, you can see it. Oh, because it shows up over the rules. Oh, perfect. Okay. So this is a thing I often am not sure about, because frequently when I've solved these sorts of puzzles on stream previously, I have had people in chat looking this up for me, and then I have to like scroll through the chat to find it. Whereas now we have this. Okay, so there's this 15 trick with arrows, and so this is the intermediate arrow trick that you may not know if you've not done a ton of arrow puzzles before. But if I pick one of these columns, I see that in this column there are 5 total cells on arrows. And so the minimum that these 5 cells together could sum to is 15. And now it's important that we take them together, because if we looked separately, you'd say, these could be as small as 3, and these could be as small as 6. But together they need to sum to at least 15, which means these 2 digits need to add to at least 15. Now what that means is they both have to be at least 6, because the smallest digit that's involved in a 2-digit sum to 15 is a 6, going with a 9. And so the same thing happens in all of these cells. So they all become 6, 7, 8, 9 because of this. And so anytime you have 5 arrow cells that all see each other, then you can apply this trick. And so the thing Jay said was, hey, okay, we're not going to use the pen tool on this one, I don't think, despite its best effort. The thing Jay said was, that gives us a 6, 7, 8, 9 quad, and so these I know are from 1, 2, 3, 4, 5. Oops. That was very exciting. 1, 2, 3, 4, 5, going there. Alrighty. Oh, a bet cell. We should have a bet cell. Let's try and do better than we did on the bet cell last time. So let's go for that cell as the bet cell. So an interesting thing about these cages is that these cages all need to have a 1, 2, and 3 in them. And Tallcat says not that cell. Choose a different one. Okay, I will choose a different cell. How about... I mean, everything in this is clued. How about that cell? So I need to have a 1, 2, and a 3 on these arrows. And that's because, again, the maximum that these arrows can sum to is 17. And conveniently, we have this 17 and 5 thing to tell you that 17 and 5 always requires a 1, 2, and 3. So the 1, 2, and 3 in this column are gone. That cannot be a 1, 2, or a 3. Likewise, that cannot be a 1, 2, or a 3. So this is interesting. Oh, okay. So we're supposed to ask about 1, 2, and 3 in row 9. That's very clever. So now where are 1, 2, and 3 in row 9? And so they're not here, here, or here. So 2 of them could go here and here. One of them has to go in a 33 cage. Now, if you squint at these two 33 cages, you'll notice by the sum magic that actually only 3 can possibly go in them. And so these have to be a 1, 2 pair. And one of these has a 3 in it. So one of these is a 3, 6, 7, 8, 9. Okay. So there's a virtual 1, 2 pair because a 6 and 2 always has a 1 or a 2 in it. So this arrow can no longer sum to 6. It now must sum to at least 7 because of this 1, 2 that has strayed over into here. So, interestingly, these two cells, I'm going to pencil mark this even though it's going to be absurd, these two cells see everywhere there's a 1, 2, and 3 in the cage. So these are always at least 4. I don't know if that does me any good, but it's true. 18 doesn't have a 3 in it. Oh, right. Okay, sorry. That isn't... I erroneously said this always had a 3 in it. It does not. Good point. Okay. So amending what I said just slightly, these are from 3, 4, 5, 6, 7, 8, 9. And this one's not 3. So that is interesting. Okay. are at most 9, so this is at least 3. Columns 6, 7, and 8. Okay, so someone is suggesting I look at 6, 7, and 8 together. And so I think the point is 17 plus 33 is 50. So that's 50. Go on right there. 73, 79, and then these sum to at most 34. So 79 plus 34 is, oh boy, this is above my pay grade. 113. So these 4 cells need to sum to at least 45 times 3 minus 113. What's 45 times 3 minus 113? Maybe not useful. 3 minus 113. If I did that right, it's 12. These 4 cells need to sum to at least 12 or at least 22. These 4 cells need to sum to at least 22. I'm doing the hard thing when there's an easy thing. Well, feel free to tell me what the easy thing is, Tristan. Oh, are you saying things like this cell has to be a 1, 2, 3 because this 1, 2, 3 has to go there? Chat said add together the stuff in columns 6, 7, and 8. Where are the 3s in columns 6, 7, 8? One of them is here. One of them is here. One of them is on the arrows. So this is so the point is this 33 cage is the 33 cage that does not have a 3 in it. So this is, so if you look at the total, okay, I'm very glad to have this 4, 7, 8, 4, 5, 7, 8, 9. Okay, so this is the 4, 5, 7, 8, 9 flavor. But as already argued, one of them has to have a 3 in it. So this one has to be the 3, 6, 7, 8, 9 flavor. The 3 needed to be in row 9. Okay. So we can get a bunch of pencil marks out of that to get this. Okay. I believe that. See, we actually have a 1, 2, 3 triple in this column. I was not really appreciating that, but it's true. Let's see. Row 2, column 2 can't be 6 because it forces the arrow below it to be 4, 5, which breaks box 7. That's very clever, yes. So if this is a 6, this has to be a 9 because remember these 2 cells need to add up to at least 15. If this is a 9, though, with this being a 6, there's a 1, 2, 3 up here. There's a 4, 5 down here, but there's definitely a 4 or a 5 in the 6 cage. So that doesn't work. So that's not a 6. So those are from 7, 8, 9. Let's see. Can do exactly the same trick here because I also can't make this a 4, 5 arrow. Because if this is a 4, 5 arrow, I can't put one of 4 and 5 into my 33 cage, which by the magic of pencil marks has to have a 4 or a 5 in it. Sorry, it has to have both a 4 and a 5 in it, so that can't be 6. And what breaks if this is 4, 5? I don't see what breaks if this is 4, 5 immediately. If that's 4, 5, then these 2 cells are 4, 5. I don't know that that does anything. there needs to be a 3 on the arrow in box 7. 6 cage has 1 of 4 and 5. Right, so I need to... I don't think I understand this. Why does there need to be a 3 here? There's a virtual 1-2 pair in the box. Okay. There's a virtual 1-2 pair in the box. So the minimum digit on this can be is 3. But if the smallest digit on this arrow... Okay, so the smallest digit on this arrow can be is 3 because of the virtual 1-2 pair. But if the smallest digit was a 4, this would be a 4-5 pair, and that's broken for the reason we have already discussed, which is that it would break the 6 cage. Okay, got it. All right, so there is a 3 on this arrow, and that 3 goes with a 4, 5, or 6. Let's see. So can't go with 6 because there's both a 3 and a 6 in here. So these are from 3, 4, 5. And now we know where the 3 goes. So now the 3 goes here, and Zach gets to do the 3 dance, which I think is the one that involves this, if I recall correctly. 3 dance. Whoop, doop, 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 doop. Whoop, doop, 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 boo. Boop, doop, boop, boop, doop, doop, doop. 3 dance. Boop, doop, boop, doop, doop, boop. Dot 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 dot. It's similar to the 8 dance because 3s and 8s look similar, but there are subtle differences which you'll have to note over time. Doop 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 doop. Thank you, Zach. That was lovely. Alrighty, so now we know that there's a 3 in one of these 2 cells. So this isn't a 3. That's not a 3, of course. So these aren't 3 is interesting. So this isn't a 9 anymore. This is a 7 or 8. There's a 6, 7, 8, 9 quad in this column. So the rest of the column is 1, 2, 3, 4, 5. So that's actually interesting because it means every digit in this 12 cage is at most 5, which means the 12 cage has to be 3, 4, 5, because otherwise you can't get to 12 because 3, 4, 5 is just 12. So that's a 3, and this is a 4, 5 pair. These aren't 3. So now the 18 cage does not have a 3 in it. So now the 18 cage I can read off is 1, 2, 4, 5, 6. Let's see. This one's not 4, 5. Well, this one's certainly not 1 or 2, because 1, 2, and 3 are on the arrows. So this is 4, 5, or 6. These can't be 4, 5, because there's a 4, 5 pair. This is a 1, 2, 3 triple. One of these 2 is a 7. The cage tool is very helpful. I don't know if when Tyrgannus set this, he imagined that I would be using the cage tool to solve it, but I think it makes killer puzzles much more pleasant. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120 upper arrow in column 5 has a 3 on it. How do I know this digit isn't a 3? Oh, because I need a 3 on... Oh, I don't know it's here. I just know it has a 3 on it. Okay, right. So there has to be a 3 on one of these two arrows. It's not here, so there's a 3 on here somewhere. And the in particular thing that tells me is that this isn't 7. That's Tall Cat's point. So this is 6, 8, or 9. This is definitely my favorite killer puzzle I've done in a while. Although I say that, and I'm not sure I completely see what to do next. 3-cell arrow in column 2 must have 1 and 2 on it. Row 3, column 2. Okay, so Tall Cat has an interesting point, which is that this digit is a none-3 sort of digit that is at most 6, because the 6 is the largest digit you can put on a 3-cell arrow. So this is 1, 2, 4, 5, 6, which makes a 1, 2, 4, 5, 6 quintuple. So this is not 4, 5, or 6. And so these digits, in fact, are all 3, 7, 8, or 9. I don't know if it does anything, but it's super cool. Wait, is this mismarked? No, I don't think it is. I think it's okay. If this were 6, this would need to be 1, 2, but that seems okay. In fact, actually, this arrow definitely has a 1 and a 2 on it, regardless of what it is. Let's see, row 3, column 2. It's the same as row 1, column 4. Right, this is in... Got it. Okay, this is in this cage. So this is a 1, 2, or a 6 because it's that digit. So I should give these a color. So this is not 4 or 5. That is a smart observation. Which makes this being a 1, 2, 6, 9 arrow really appealing. But I don't know. Ah, 6. So Kurabon is pointing out that 6 in column 3 is locked into being over here. So in particular, this is not a 6. So this is either a locked candidate or a pointing something something, depending on your philosophy of naming Sudoku things. So that gives us our 7, 8, 9 triple in the column. So the 6 is either here or it's on... or it's on one of the arrows. Let's see. Okay, so So probably there's some parity thing, isn't there? No, maybe not quite. Let's see. I think like there's probably some math I could do to get this cell, but I only want to if I absolutely... Hello? Okay, I think I'm back. I think there was a brief hiccup. But I think I'm back now. Can everyone see me? Hello! Hello! Excellent. Alright, I am back. Woohoo! Okay, I am back now. This cell is not a 3. I have seen this. Alright. Huh, this is interesting. This cell and this cell are the same digit. Because whatever this cell is, it has to go in column... it has to go in column 7, and it can't repeat in the cage. And the other of 1 and 2 and 3 are in this cage. So these two are the same digit, which may or may not be the same digit as yellow. Actually, I can prove that it can't be the same digit as yellow, but I will save the proof that it can't be the same digit as yellow for the Patreon. Let's see. So this digit purple is either on the arrow here over here. Let's see. Row 1, column 8. What can it be? Let's see. So it can't be from 1, 2, 3, so it has to be from 4, 5, 6, 7 is the most it could possibly be. Can't be 6 because of the 18 cage. Oh, right. The 18 cage has a 6 in it, right? There's a sort of invisible... one of these two became a 6. After that 6 knocked the 6 out of this part of the T, one of these two is a 6. So these are not 6. And this 17 cage is actually the only cage I don't know the composition of. Well, sorry, that's not true. There are these little 2-cell cages that I don't know the composition of. But this is the biggest cage that I don't know the composition of. Okay, so that's like kind of a quad-ish, sort of. Not really. If I can make this not be allowed to be 6, does that tell me that then I actually do have a... No, I'd still have a quad... Or sorry, I'd still have 4 pieces of a quint, is the moral of the story there. I know yellow goes in one of these 2 cells, but I do not know which. I actually know... Oh, no, I don't. Purple could go here. I was looking at where purple was going to go on these arrows. But I don't think it's useful. And this digit could be a 5. This is not a 3. I agree with that. And so it has to go in the 18 cage. So it's one of those two cells. But I don't know if that helps. Purple in box 5 is in one of these two cells. Okay, good to know. This can't be 4-5. Okay, so this is a good point. Okay, this can't be 4-5, because if it's a 4-5, then I can't put a 4 or a 5 in the 17 cage, and as you can see, I need a 4 or a 5 in the 17 cage. So therefore, there's a 1, 2, or 3 in this. There's two 1, 2, 3s over here. So therefore, this digit's at least 4. Also, it can't be bigger than 6. So this is a 4, 5, or 6, is the point that is being made by Tallcat, I believe. So now if this is at least 4, these digits are... Yeah, these digits are at most 3. Good. Okay, that's a very clever point. Okay. So this digit's at least 4. So I cannot put any digits that are higher than 4 or equal to 4 on this arrow, or it will sum to more than 9. So these digits can only come from 1, 2, 3, which gives us a 1, 2, 3 triple inside this box. Which means these come from 4, 5, 6, 7, 8, 9. I don't know if it's useful, but maybe someday I'll get a 4, 5, 6, 7, 8, 9 triple or something that'll be helpful. So 1, 2 pair in row 5. Oh, because this is not a 3. Right. This is not a 3 because of the 3 there. So this is a 1, 2 pair. Okay, this digit is also huge now. Okay, so this is going to help. This is going to help a lot because now this digit can't be 1, 2, or 3. So in fact, these are also from the same sort of deal. This is a 4, 5, or 6. So this can't be a 6. And so that's not a 6. And so yellow and purple actually are legitimate, honest, small digits, which is what we wanted them to be. So that is actually huge. So this is the big digit. So this is also 1, 2, or 3 for the same reason about things. So this is a 1, 2, 3 triple. So this is again a big digit. 4, 5, 6, 7, 8, 9. So where's the other? No, we already are done with 1, 2s, and 3s for the column. Because we've got 2 1, 2, 3s down here, and then we've got one over there. This can't be a 3 because there's a 3 in the box. So in fact, these two sum to 3. So yellow has to make an appearance in this cage. Oh, but it was purple I knew something about. Yeah, yellow is one of these two. 6 in box 1. Oh, right. So now we know where the 6 goes in box 1. Excellent point from Franco. So that's a 6. So this isn't a 6. Very good. So now this can't be a 9 anymore. So now this is a 7-8 pair. Which I guess makes sense. So now this is a 9. Speaking of things that are or are not 9. These aren't 9. Sorry, 6. So these are 6, 7, 8. And so that 6, 7, 8 triple gives me a 9 here. Means these aren't 9. Means a bunch of other things aren't 9, like that and that and that and that and that and that. In fact, this is no. Sorry. Don't look at me. That's not one of the things, because that's... I do, however, know that one of these two is 9, so therefore this is not 9. That I do know. Nine in row 9 looks right. Very good. So these are not 9, so there's now a 9 in one of these. So this isn't a 9, which gives us a 6-8 pair, and the 23 cage makes that a 9. Very good. Can I color the other 1, 2, 3? Is a thing I would like to know. Because I think it might help if I colored all of 1, 2, and 3, but I'm not sure that I actually can, because I don't know that there's a single 1, 2, 3 that I know is the one that's not purple or yellow. This can't be 9. This is Chris's point. And so as soon as this can't be 9, this can't be 6 anymore. So this is now 8 or 9. So this cell is not 1, 2, or 3. This cell is 4, 5, or 6. Let's see, that's 1, 2, 4, 5, 6s for the row. Not bad. We're getting a decent collection of 4, 5, 6s. Okay, so we've got our 7, 8, 9 triple now. So this is a 3, owing to that. I felt like there was supposed to be some way early I was supposed to know that these weren't 6, because there were like 2 back-to-back really nice deductions that these two weren't 6s. I was expecting there to be a way to get that this wasn't 6. There might or might not have been, but I was expecting early on, just from the way the puzzle was set, that was going to happen. But maybe it is just a delayed gratification thing. Welcome back, Panthera, by the way. 3 in box 2 I can do a thing with, I am told. It's purple. I think I'm missing something. 7, 8. Triple in column 6. Sure, because it's on the arrow. Wait, you mean this isn't on the arrow? Is that what we're saying? One of these two is yellow. I believe that. Purple is the only place 3 can go in box 2. Right. 3 can't go here because of the arrow triples. 3 can't go in either of these two places. And 3 can't go here because the 1, 2, 3 triple. Okay, that's very complicated for me to see. But if you put together everything we've said, 3 can't go here because there's a 1, 2, 3 triple on the arrows. 3 can't go here or here because of the 3 there. And 3 can't go in this column because of the 1, 2, 3 triple in this column. So therefore purple is 3. And we can demote it. So these are not 3. That is not a 3. So 1, 2 pair. So that's a 3. And so now if this is a 3, that can't possibly be a 6. And so now 3 in box 3 is known because 3 cannot repeat inside the 17 cage. So 3 is it. That's slick. And so that's a 6. So this is not a 6. These aren't a 6. So one of these two is a 6. Which is hilarious, because one of the... Oh, no, sorry, I don't know that. Never mind. This could be the 6. I was going to get to do something so cool, too. I already have a 3 in box 6. Ah, this isn't a 3, is the point. So this is not a 9 anymore. This is a 7 or an 8. So this is the one that's the 9, because this can't get up to a total of 9 anymore. So that's a 9. So these two add to 6. So 9 in one of these two cells. Oh, this arrow can't sum to 6 because it would need a 1 or a 2 and it can't have it. So now I get to do the cool thing, which is that 6 in this box goes in one of these two places and they both see this cell. And so because 6 goes in one of these two places and they both see this cell can't be a 6. And ergo that cell is an 8 and that cell is a 6. And so now that's a 7 and an 8. That is not an 8. Well, the 8 in box 8 does not go on the arrow. So the 8 in box 8 goes here. Oops. No, not restart. So these are not 8s. And that's not an 8. Actually, that 4, 5, 7 triple that apparently we have out of nowhere makes that an 8, 9, and makes that a 6. So these aren't 6 anymore. Fortunately, I have done that before, and actually Sven's software lets you rewind if you screw up and accidentally hit restart when you don't mean to. I don't, strictly speaking, recommend it, but it is a thing that is possible. So now where are 8 and 9 in column 8? Namely, the only places 8 and 9 in column 8 can possibly go are in the arrow circles because of this 8-9 pair. So therefore, that's an 8 and that's a 9. Oops. Sorry, that's an 8 and that's a 9, which means that that's a 5. This now has to be a 3, 6. No row 4. I don't think I saw the thing that was talked about with row 4. Let's see. So row 4 I'm looking at now. Let's clean it up a little. So these are not 8 or 7. So that's a 4, 5 pair. So these aren't 4 or 5. That one's not a 9 either. So that 4-5 pair gives us a 6 over here. That's not a 6. I was having more fun with my hidden 8-5, but whatever. This is not a 5. Okay, so that 4-5 gave me this 7-8. That 7-8 tells me that's not a 7 or an 8. It's a 4 or a 9. Don't think I know what's going on up there yet. Let's see. Okay. Okay, this is a 1, 2, 4, 5. This is a 1, 2, 4, 5. 9 can't go in a 17 cage. That is a good point. So now 9 in this box now has to go here. Beautiful. So now we know the contents of this cage. And so now it is irrelevant, but we'll fill them in anyway. Namely, it is 1, 2, 4, 7 is the contents of this cage. This can't be a 5. Let's see. These digits are actually quite restricted. They're from 1, 2, not 3, 4, 5, 6, 7, 8, 9. They're from 1, 2, 4, 5. So that means that the last of 1, 2, 4, 5 is here. And then one of these has to be a 7. So this isn't a 7. So that is a 4 or a 5. Let's see. 8 in row 1. 8 in row 1, just by Sudoku, is placed here. So that's a 7. So that's an 8. So that's a 4. So this is a 3, 5. So that's a 9. Excellent spot by Sayori there. So this being a 3, 5 means this is a 2, 4. Means this is a 1. Shh, Naverio, don't give it away. This is a 2. These aren't 2. Let's see. 4, 5. Yep. This is not 1, 2, 3, 4. Could be 5. It can't be 6. Could be 7. Can't be 8 or 9. So this is 5 or 7 only. This is not a 4, though. Let's see. Okay, this is not a 4. It's not an 8. It's a 5 or a 7. So that's a 5, 7 pair. So that's not a 5. So let's see. That 5 over there fixes this 4, which fixes that 2, which makes that a 1 and that a 2, which makes that a 4 and that a 2, which makes that a 1 and that a 2, which makes that a 1 and that a 2. Yellow is 2. So if you were betting that yellow would be 2 in your betting game, yellow is 2. These are not 2, so that is 2. So let's see. So this row no longer needs a 4. No longer needs a 4 or a 2. So, or a 5, actually. So that's a 1. That's a 7. I probably know what this is. I think it's a 6. These aren't 1 anymore. These aren't 7 anymore. So therefore, that's a 4. 4 goes away. That's a 7. This is not a 7. Got a 4, 5 pair, like you like to do. There's a 2 in the row already. So, what did I do? Or did Tall Cat just want to put the woo-woo thing on? Miss pencil mark in box 1. Oh, I should just delete these pencil marks. And then I can do this correctly. Maybe. These are supposed to be 4, 5. And so that's a 5 and that's a 4. That's a 1, that's a 2. That's a something. 3, 4, 5, 6, 7. Let's see. One of these is a 1, and it's that one. That's a 5. So that's a 4, and that's a 5. So that's a 4, and that's a 5. This is very satisfying to unwind. That's a 1, and that's a 4. Let's see. I should probably look closelier at what's actually happening. That 8 looks over and gives me a 7 and an 8. That 7 and 8 give me a 6 here. The 6 here has got to be a sum of 1 and 5, which has got to look like that, which gives me the 3 and the 5 over here. The 2, 3, 4, 5, 6, 7 goes here, so that's an 8 and a 7. That 8 gives me the 9 and the 8. The 3 gives me the 6 and the 3. 2, 3, 4, 5, 6. 6 goes there. 4, 5, 6, 7, 8, 9 goes there. Let's see. And so let's see if we can resolve the last bit here. So this 7 gives me a 5 there, which gives me a 4 there, and a 5 there, and a 7 there. We got the bet cell last, so I did a very good job of picking the bet cell, no matter what Naverio tells you about having psychically guessed the bet cell earlier. That was very cool. I liked that. And I think this is the first time I've actually gotten to use the calculator from Sven. But I think this has real potential, actually, to sort of smooth out exactly... it standardizes what setters expect out of solvers from a killer puzzle. Because historically, there have been setters who want you to basically only do it if it's maximum or 1 from maximum. And if you're looking at a killer cage and it's neither maximum nor 1 from maximum, then you shouldn't be looking at it. And then there's setters like Tyrgannus, who I know is a killer cage expert, who is the like killer cage whisperer, along with Clover, that sort of like knows every total and size combination and exactly when to use them for what kind of deduction, which is beautifully executed here, especially in the combination with the arrows. The sort of setup of okay, these things have to add up at least this. I really enjoyed that. That was very, very snappy, at least when I was paying close attention. I think there were a couple things that took a while for me to see. And I also got derailed trying to add these up rather than asking about where the 3 was. Yes, Tyrgannus is an expert setter. Who also now does gaps. Alrighty, I'm going to take a short break, and then we'll be back with one more puzzle of some description. I will find it, and then we will do it. Well, chat said look at columns 6, 7, and 8. What was I going to do? I was going to add up all the cages, but that turned out not to be a smart thing to do. But I 100% agree. Chat knew what I should do and was trying to get me to do it. I just, when I saw chat's suggestion, thought, oh, I should do this other crazy thing that was not a good idea. You missed me attempting to subtract something from 3 times 45 that was some gigantic number that was totally irrelevant to the puzzle. But I will be back shortly with another puzzle of some sort. Be right back. Alrighty, welcome back. I'm going to do this this Renbon quadruple puzzle. One Renbon and quadruple both being favorites. I don't think I need the killer calculator for the Renbon quadruple puzzle. By BremSter and the Skunkwork gang. BremSter being a friend of the channel and fellow user of the Puzzle Plaza Discord, or fellow person of the friend of the channel Renbon. I mean, not gonna lie, the channel does love Renbon. How does this work? So every one of these purple lines contains a string of consecutive digits in any order. So for example, the digits on this line could be 3, 4, 5, 6, 7. And they could go in absolutely any order they wanted, as long as they were a string of consecutive digits. The thing you cannot do is you cannot repeat things. So you could not put the same digit here and here, for example. Then it will not be a string of consecutive digits. It will be a string of consecutive digits with repeats. And that is just verboten. The quadruples here give you some digits that occur in the surrounding cells. So, for example, in these cells, I know there is a 2 and a 3. And I will make some deductions based on that in a second. But that's the rules of the puzzle. So the first thing that I'm going to notice is that either a 2 or a 3 is on this Renbon. So definitely a 3 is on this Renbon. Because if I tried to put a 2 but not a 3 on this Renbon, I'm going to run out of digits way before I run out of Renbon. Now, this 3 quad is now interesting, because this 3 quad now can't get its 3 from down here, because there's a 3 down here. So one of these cells is a 3. Tristan, can you put a link in the chat? He will in a second if he has... if he's not, he may be disappeared briefly. There's a 3 over here, which I can now chase over to this 2-3 quad, which gives us a 3 here, and that's going to give us our first digit, which is the 3 dance, or the 3 digit. And so that 3 will let us bring out Zach for our 3 dance, which I believe goes something like this. I think we may have done the first 3 dance earlier today, but woo, woo. Thank you, Zach. Much appreciated. Oops. Oh, bet cell again. Yes. How about that? Okay, that's not a good choice. That. How about that for a bet cell? Yes, like the 8 dance, but more horizontal is correct. As 3s are like 8s, but more horizontal. Well, there's always a little flourish at the end, you know. Zach gets to improvise some at the end of the ritual. This is not a 3. We can confirm. There's a 3 over here. Okay, so I should probably think about the same thing about the 7 and 8 here. So there's a 7 and an 8 around this quad. Likewise, this can't be the 7, because then it would require because then it would put an 8 on this quad, an 8 on this Renbon, but not have access to a 7. That would be a big problem. What digits do I know for sure are on this Renbon? So it could have a 1 and a 2, but then it's going to still have a 4 and a 5 regardless. That is the moral of this story. Likewise, this Renbon is going to require... Well, it's got a 3 on it. Could have 1, 2. It's also going to require a 4 and a 5. Okay, this has gotten rather ridiculous in terms of corner marking things. But that is cool. Okay. Okay. I see something. And I think this is what chat was talking about. This 7-8 quad goes on this Renbon for sure. So this Renbon can't have any more 7s or 8s on it. So therefore this quad actually puts a 7-8 here, which then forces this 6-9 quad to put the 6-9 there. Obligatory nice. And so now these are the remaining digits. They're 1, 2, 3, 4, 5. I know this isn't a 1 or a 4. I had not previously appreciated that these Renbons were 9 cells long. They look much shorter than 9 cells if you look. But alas, they are not. Okay. So likewise, the 2, 3 that are placed down here mean that I can't put a 2, 3 in either of these cells. So these actually are where I put the 2, 3 for this one. So in fact, this digit is a 5. These are not 2 or 3 or 5. They are 1 and 4. So these aren't 4 or 5. If I look at the row, okay, so this Renbon has a 3 on it. Can it have a 7 or an 8 on it? 3, 4, 5, 6, 7. It can have a 7, but not an 8. Okay, so now the 8 in row 5 is definitely over here. So these are not 8s. So there is an 8 over down here, possibly a 7. And now I bet I could do the same thing for 2s. Where is the 2 in this row? Well, the 2 can't go with a 7 or an 8. So the 2 is actually legitimately over here. So these aren't 2. The 3 could just go with the 7, unfortunately. But what are you going to do? So that's all well and good. The quads in box 5. The quads in box 5 are very helpful, as Directionary points out. The 4 tells me this isn't a 4, so that's a 1 and a 4. And the 9 tells me this isn't a 9, so that's a 6 and a 9. That 4 tells me that that exact cell is a 4, because I need a 4 on this quadruple. And I'm not getting one anywhere else. So that tells me that one of these 2 cells is a 4. Now, the fact that one of those 2 cells is a 4, and also there is a 4 on this Renbon, given that it is length 9, tells me that one of these 2 cells is a 4. 3 in row 6 is placed. Right, because now this Renbon doesn't have a 4 on it. Beautiful. Okay. This Renbon no longer has a 4 on it, and so since it doesn't have a 4, it also does not have a 3, because the only way to get from 7 to 4 is to, or sorry, from 7 to 3 is to go through 4. And so beautifully, yes, that's a 3 now, because now the 3 for the row has to go there, and now I still need a 2 for the row, which is going to have to go there. Gorgeous observation. So this is now a 7-8 pair. So this is a 7-8 pair. These are, by the way, I know exactly what's on this Renbon. It is now a 5, 6, 9, 5, 6, 7, 8, 9, because I can't have a 4, and that's all that's left. So these digits are a 1, 2, 3 in some order. So that gives me a 1, 2, 3 triple in this column, actually. So I can actually fill in 5, 6, 7, 8, 9 to go through the rest of this. So, in fact, I can't have a 9 in this column on this Renbon. 4 does not connect to 9. 4 connects just barely to 8. So the 9 is actually down here. Am I sure my logic with the 4 in row 7 is correct? So my logic was that... Oh, no, it's not correct. Good point. Okay, so sorry. That was completely wrong. Okay. I see the problem now. So my logic was, there are aligned 4s between this Renbon and these two 4s. Great. Except there's a significant problem with that, which is that there could be a 4 over here. So that does not work. However, the thing I said about this Renbon being 5, 6, 7, 8, 9, that part's still right. And these are not 6 or 9 or 5. So they're 7, 8. These are not 7 or 8. These are still 1, 2, 3. It is still a 2, 3 pair down here, and I know where the 3 is. So that's not a 3. And these are a 4 and a 5, and then either a 1 or a 6. I don't know which. All right. So these digits are a 1, a 6, and a 7 or an 8. Okay. 2 is given in box 9. Ah, yes, very nice by JLib. 2 has to go here now. Because of, because it doesn't have anywhere else to go on this, on this tuple. And so that gives us a 3 as well. For free. All right. So there needs to be a 2 up here somewhere. I can mark for the future. So, beautiful. Okay. 3 in box 8. Very nice. Okay. 3 in box 8 cannot go here, cannot repeat on the whisper. And so the 3 in box 8 is in one of these two cells, except one of these two cells is a 3. So this can't be a 3. So therefore it must be that that's the 3 and that's the 2. That's a very clever setting. So neither of these is the 2. So that is the 2. Over there. So there's a 2 up over here as well. By the way, welcome, BremSter, setter of the puzzle. Renbon and quads are two of my favorite Sudoku things. So this was, as soon as I saw this one, I was like, well, I'm definitely doing that. Let's see. This 7-8 has to go over here somewhere for whatever it's worth. Oh, interesting. Okay, so I need to put a 7-8 in this column up here. So this Renbon definitely has a 7 or an 8 on it, because I cannot put both 7 and 8 there. Wait, no, I could. Never mind. Don't listen to me. Oh, well, if I did put both 7 and 8 here, I would have to put a 9 up here, and then that would create all sorts of problems. I think I'm probably not thinking about the desired thing, but I think I can actually prove something. So, I can't possibly have a 9 on this Renbon, because if I do, then I'm going to need a 9 and a 7-8 over here, which is going to require... No, don't listen to me. I think I'm full of nonsense today. Okay. So the 3 is over here. I can say that much. Let's do real things. Oh, 9 can't go with a 4. Right. Okay. That was a much better argument. 9 can't go with 4. So the 9 is down here. So there's a 9 over here. Tallcat tells me I made that argument. Old me must have been smart. Let's see. Where does row 7, column 7 go in box 6? This is a 7, 8. And Garian beautifully points out it needs to go here. So this cell is a 7 or an 8. It's not a 1 or a 6. Oops. Very wise. Thank you, BremSter. I was really happy to see that one make it. 7 or 8, and this 7 or 8 needs to go in one of those two cells. I don't know which one. 9 could be pencil marked in box 8. Sure can, because 9 can't repeat on this Renbon, so 9 is in one of these two cells. And so 9 is in one of these two cells. And so I need to figure out how to fit 9 on this long Renbon, because I suspect this has length enough, right? 1, 2, 3, 4, 5, 6, 7. Okay. When I looked at this puzzle, I assumed these Renbons were length 7 and this Renbon was length 9, but this Renbon is not length 9. This Renbon is only length 7, and it has a 2 on it. So it could have a 2 and an 8 on it, but it might not have a 9 on it at all. It definitely, though, needs to have a 4 on it, and there's only one place that can go, because these can't be 4, and none of these can be 4. So this Renbon always has a 4. That 4 has to go exactly there. And in fact, actually, it can't even have a 9 on it because 2 and 9 don't go together. So actually, not only does it not need to have a 9, it actually cannot have a 9, as Jaleb points out. This cell, not a 4. And like all Renbons, this Renbon needs a 5, and one of these two cells now are the only two places that it can go. So that's not a 5. I can be more aggressive in my pencil marking of column 3, I am told. Let's see. So, can I put an 8 here? If I put an 8 here, oh, the point is this 7, 8 needs to go on this quadruple, so it goes over here. So the point is that this is a 7... Sorry, I destroyed the world. These two cells are from 7, 8, 9 only. That is the point. And this is never an 8, because it would break this 8 quad. This is also never an 8. So in fact, one of these two is an 8. However, if this cell was an 8, no, I think that's okay. Never mind. Hey, Tyrgannus, I really enjoyed your puzzle. Okay. Row 4, column 3. Okay, this Renbon needs a 3. Okay, good spot. Okay, this Renbon needs a 3. Where is it getting it? Well, only here. 3 and 1. So this is not a 1. This is not a 1. 4 in row 4 does things. Okay, yes, the 4 in row 4 does look right over here, making this a 4. So these are not 4 anymore. One of the two of them is a 5. I should actually... Okay, one of them is a 5, which means these aren't 5, which makes that a 6-9 pair, which makes that a 5. 6-9 looks back over, gets rid of 6s here. So this is now a 1-5 pair, so that's not a 1. This is a 7-8 pair, so that's a 6. Now I need a 6 on the M, so actually this is a 5-6 pair to do that. And that's resolved. And then Jaleb has a point that I must consider. The M can't have a 9 on it. Wait. Where does 2 go in box 8? It goes... it joins the 9 to make a 2-9 pair. Like that. That is a good observation. Okay, so these two cells... Oh, well, that's not a 9 anymore because of the 6-9 pair, so that's the 9. So these two, I should know what they are. They should be a 2 and a something. 3, 4, 5, 6... Oh, sorry, and a 7 or an 8, but I don't know which of 7 and 8. And likewise, these are a 3, 4, 5, 6, 7, or an 8. These are a 3, and a 7, or an 8. Okay. Except that one's not the 3. So this one is the 3. To go there. Okay. So now, this column, we've still need to find a 1. We don't have 2, 3, 4, 5. We need to find a 6, 7, and an 8. Well, I know where the 6 goes, because none of those are 6. So this is a hidden single 6 or something. So these are 1, 7, 8. So let's fill in these. 2, 3, 4, 5, 6, 7, 8, 9. These we know aren't 9. These we know aren't 3 by the quadruple. Let's see. 2, 4, 9. That's disappointing. Let's see. 2 in row 7. I have a 2 in row 7. What is the 2 in row 7 doing that I'm missing? I did realize some time ago this cell can't actually be a 2, but I didn't really want to explain it. Because this cell can't be a 2 because it would require a 3 on the Renbon, so I didn't mark it. Is that what we're talking about? 4 in row 7? Let's see, 4 in row 7. 4 in row 7, because if this 4 can't go there, and so the 4 in row 7 is actually placed there. Very good observation. The observation I made about aligning 4s previously became relevant once, or became actually true once this was a 2-3. I just didn't recapture it. So these are a 1, 2, 3, 4, 5. These are a 1, 4, 5. So therefore that's a 2. In order to make this Renbon do its Renbon stuff. So this isn't a 2. This isn't a 2. Yes, because it's late in the stream. My scanning is not good. 6, 7, 8, 9. This one's not a 6. This one isn't a 4. I felt bad for people making fun of Simon's scanning and solving my puzzle today, but I guess it goes with the territory of being Simon, that people will make fun of you for your scanning. Oh, it's also not a 5, because of this 5 all the way across the grid. It was hard to see. So this is a 4-5 pair. Row 7, column 5 is resolved. I see. So when people are talking about this 2, it's possible that the people who are talking about this 2 were looking at this digit I'm not sure. No one can be certain. But okay, so that does maybe something, maybe possibly. I know one of these is a 9. There's got to be a 1 in here somewhere. So one of these is a 1. 2, 3. One of these has got to be a 4, but it's getting into... it's getting beyond the pale, I feel, at this point. I'm just going to leave it at one of those as a 1. Let's see. The 2 in this column is up here. The 3 in this column is definitely up here. 4 in this column could be up here. Let's see. 2 in row 3. So 2 in row 3 actually is only here. Good spot to Sayori. So this isn't a 1, by the way. Sorry, I pencil marked the wrong thing. This isn't a 1. So this is a 7, 8, or 9. It can't be a 9, actually, because 9 and 4 can't go in a length 5 Ren bond together. Apparently, I said that earlier, so I'll say it again. 7 and 8 give me a 9 over here. These aren't 9. Let's see. Yeah, I seem to recall he messed up the negative constraint on a broken 159 puzzle. I have been there many times. Okay, so there's a 7, 8, 9 triple out of nowhere in this column. So actually, these digits are known. They are a 5, 6, and something else. No, they're just a 5 and a 6. So this is 4, 5, 6, and then we've got a 7 or an 8. So we've either got a 7 or an 8 or a 3. Those are the options for this cell. Let's see. I don't know, my theory is a lot of times that chat is terse. It's not that they're trying to be mean. They're just trying to communicate efficiently because they're like fumbling it in a phone and don't want to type something long or whatever. That is my interpretation of why chat sometimes is not as kind as they could be. 7, 8, and 9. Okay, why on earth did I pencil mark that? What did I think I was going to get out of that? I could not even begin to tell you what I thought was going to happen with that, but that is okay. These would be much more better to pencil mark, much more goodly. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nope, just 1, 5, 6. Okay, this is not 5. Let's see. Okay. I can't have a 7 here. I can't have a 7 in any of these cells. Because if I have a 7 in any of those cells, then that is going to put an 8 here, and that's going to cause a huge problem. I love watching Simon solve puzzles. It's so much fun. Okay, what am I missing? I mean, I'm sure the answer is a lot of things. There's a 6, 7, 8 triple in this column. That's what I'm missing. So these digits are from 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the only digits that can go there. So one of these digits is a 6. Because basically there's the 6 in this triple is locked up here. That's the thing I was supposed to notice. So this can't be a 6. This certainly can't be a 6. I could never have been a 6. Don't know why I pencil marked it as being able to be a 6, but whatever. So these are from 6, 7, 8. One of them is a 6. Now, why did I think that was going to be helpful? Because that can't be a 6 either, so that's a 6. Let's see. Who knows? Alrighty. I can color just recreationally. Row 8, column 6. And row 9, column 6 are a 1-4 pair. How do I know the 4 isn't over here? Okay, what am I missing about 4s? I think I'm missing something about a 4 that chat has seen that I have not. Row 9, column 3 is an 8. Row 9, column 3 in row 8. Oh, sorry, in row 8. Got it, it's one of those two. And one of those two. Okay. All right, so I think Agarian is suggesting just go through all of this. So there's no 2, 3. There's no 6 or 9. Let's see. I know there needs to be a 7 or an 8. I know there's no 1 from that. There needs to be a 5 here, I am now realizing. Oh, it was these cells. These were the cells that Garian was talking about. Oops. So not 2, 3, not 9, not 6. Not 7 or 8 because there's a 7, 8 virtual pair in... Wait, no, they could be 7, 8, couldn't they? No, they can't be 7, 8 because there's a 7, 8 on the Renbon from this. And not 5. Okay, so yes, completely right. This is a 1-4 pair. I would really like to know how you saw that. But this is a 1-4 pair. Beautiful. So these aren't 4. So the 1-4 pair up here gives me a 3 and a 2. This is not a 2. So this is a 2. So this is not a 2. Let's see. This 3 do anything? Okay. So there's no longer a 3 on this. So this is now a 7, 8 pair. So those aren't 8. Oops. Those aren't 8. That's not 8 either. Row 8, column 3, and row 9. Right, so this digit in row 9 has to go there, which means these digits are both 9s. Good spot to Chris. 7 and 8 go in, so 5 goes in. This is now a 1, that's a 5. So that's a 1 and that's a 5. This is just a fun puzzle. I like this. When it started, I was like, oh, this is kind of like a gas puzzle, but I think this is a little north of that, but not too far over the line in terms of difficulty. So these are 3, 4, 5, 6, 7, 8. These are not 5. These are not 4. These are not 8. These could be literally anything, I think. Oh, yeah, this would certainly be a fun feature. Row 9, column 2 is a 5. 8 has to be on the quad. Oh, yes, 8 has to be on the quad. That is an excellent point. There's a quad that I have somehow forgotten existed, but this needs an 8, and it can only get it from there. So that is an 8. It's a 7 and an 8. So that 3-4 pair makes that a 5. 3 looks over, makes that a 4 and a 3. 4 looks over, makes that a 1 and a 4. The 8 looks over and makes that a 7 and an 8, a 7, and an 8 and a 7, and an 8 and a 7. Let's see. These aren't 8. So that is 8. That's not 8. Okay, there must be... Is there a quad I haven't used? Or am I just not looking at something? 8 looks up in column 1. I've just not looked up column 1, apparently. So this is now the 7, and that's the 8. That's the 7, the 1, and the bet cell is an 8. Congratulations if you bet 8. So the 1 looks over here, makes that a 1. Makes that a 6 and a 1. Makes that a 9 and a 6. Makes that a 3 and a 9. That makes that a 4 and a 9. Makes that a 5 and a 4. Makes that a 6 and a 7. Makes that a 5 and a 6. Woohoo! Very nice. Thank you for the puzzle. That is a very cool puzzle, BremSter. I enjoyed that a lot. I'm just such a sucker for Renbon. Renbon is fun. And I think quads are underutilized as a Sudoku mechanic. So it's very cool to have a combination. So you said this is from a pack? If you want, you can send Tristan a link, and Tristan can plug the whole pack in chat if you would like. So if people want more puzzles of this sort, I did a pack of 40 of them. That is a lot of puzzles. I admit, my assumption, and this could be wrong, but generally when I see packs, I think, okay, well, this is someone who made a lot of decent puzzles, and then I tend to think that if I'm looking for, like, the cream of the crop, everyone's favorite puzzle, I tend to assume that, like, everyone's awesome puzzle they published separately. So I tend not to dig into packs a lot, but maybe I should more. I don't know. I guess some people really like making packs. And it is cool that there are so many Sudoku puzzles around. I guess the packs are a lot like the CTC apps, where it's sort of like you could just binge the puzzles, which would be cool. But that could just be a me thing. Alrighty, well, thank you for joining me today, everyone. We got to have a bit of a deviation from our usual schedule of sort of taking a break to go do the thing. Well, Grockles just breathes out Sudoku puzzles. I mean, Grockles is not a fair comparison for setting. Oh, we have a new patron, Jim. Thank you. Welcome, Jim. Very happy to have you. I'm going to head off for now. I've got to catch up on my Survivor viewing. But I will see you all on Saturday when we will have, I'm sure, more fun puzzles. For all of you who now have fancy windmill powers, you should go vote, see how many votes we can get up to the top puzzle. I think you already voted for the puzzle that I found most terrifying, so the next one should be less terrifying, ? Thank you to the mods. Thank you to the supporters, who, however you support, be it by subscribing, by coming, by helping in chat, by liking the stream. Especially thank you to those of you who donate, particularly Franco and David Ratner, who've both been incredibly generous. Thank you so much. I look forward to seeing you all on Saturday. Have a great evening or morning if it is morning for you, or whatever time of day it is. Have a great one. I'll see you soon.
Yeah.